Hey, this is Coffee Compiler Club, here to talk about compilers and language runtimes and typing systems and anything in between, or solar panels or whatever. And you're being videoed. You'll show up on YouTube within, an hour to a day. And that's it. I think everyone here is pretty much a regular now. It's all good. So no set agenda, whatever we want to talk about, including solar panels.
Yeah, I can kick it off with a potential controversial topic.
Fire away.
Yeah.
Dependency management.
Oh,
So the backstory there is I'm working on a package manager for my language. And I've kind of already decided I don't want to use the usual complicated SAT solving algorithms for figuring out versions that you have to pick. So like Ruby, you can specify, oh, of this dependency, I need at least version A, at most version B, but I want to skip version C, which is in between, like all these complex rules. And so I found that the approach Go takes, which they wrote about in the past, is quite interesting, where you specify instead your minimum required version. And then the system tries to basically pick the highest minimum version. So if you have three packages, one says, oh, I need version 1.2. The other one says, I need version 1.5. And the third one says, I need 1.9. It will pick 1.9 because that is the basically the minimum requirement that satisfies all of them.
Okay.
And then
the min of the max.
Right. And so that is super easy to implement. It's like 10 lines of code, basically.
Right.
But then what they did is for major versions, they decided that the major versions are essentially different packages. And that also affects your import paths. So you import version 0 or 1 of the JSON library, it's just, import JSON. But then if you want version 2, it's like import JSON /v2 or something like that.
.v, yeah.
Now, Go made the weird choice.
Seems like you're putting a lot of faith in the package maintainers to get semantic versioning correct.
Right.
Right. I didn't want to say that yet, but exactly.
Right. So that's one thing. The other thing, I think the mistake they made there is they made it so that versions 0 and 1, you don't have to stick the version in your import path because they're supposed to be compatible, which in practice is never the case. Like any library at version 0 going to 1 usually has some changes. But it also introduces ambiguity, where if you do import JSON, you might start your project using version 0. And then if a dependency introduces version 1, I haven't figured out how Go deals with that, because then the import is ambiguous. It could be 0 or 1. But anyway,
I think it's even worse. I think if you don't put a version number, you will get the master or the head of master main branch in the GitHub repository. So it's even worse.
I think that's no longer the case with their dependency.
Isn't it? Maybe.
But anyway, the point being, the idea is that you basically make the version part of your import so that you can have multiple major versions of the same package in your dependency graph somewhere. And the idea behind it, as far as I understood, was that in theory, it makes upgrading easier. Because the case you might have is you depend on some library that depends on, say, an AWS SDK version 1 point whatever. And you use version 1 point whatever also. But if then that library updates to version 2, ideally, you don't want to have to go through your code and change everything accordingly. And this idea,
version numbers in the code, is that what I heard right? In the import
statement. Well, let's say for a moment the major version is always there, because that solves that ambiguity problem. So instead of doing import AWS, you do like import AWS /v1, for example. And then somewhere in some file you say, oh, I need at least 1.2.3. And then some dependency users, they at some point decide to go from v1 to v2, so they change
both in your source and in some other file. Why having it in 2 places?
Well, so that's the truth. So that the idea is, if I remember correctly, is that the import is always. I think the whole idea was that if you have a particular import path, if that doesn't change, whatever code it points to should be compatible. So in other words, if you say I want to import full version 1,
right,
it should always basically be the same, right? And so that kind of I agree. Whereas if you just do import AWS, it could be any version in theory.
No, I have a different question. You said and there's a file somewhere else that has, I want.
Okay, so let's say you have some web application that you're building. You need AWS version 1.
Yeah.
You have some library that you depend on, which then also depends on the AWS library. And at some point, that library in between decides, hey, we're going to start using version 2.
Yeah.
In a lot of languages like Ruby, Python, whatever, this introduces annoyances because you will at some point update that library in between and it will say, hey, I need version 2, but you're still using version 1. What the hell? Whereas in the Go model, you don't have that problem because it essentially are different packages. And so on paper, this seems like an interesting approach. Now I've been messing with it. It is kind of annoying, and at least in my case, for various reasons to implement. But there is a sort of catch in that while it is true you can have multiple major versions exist in your dependency graph, you might actually still not be able to use them. So the case is if you have some type produced by version 1 of some package, you do something with that, and then through another library, you end up passing that to version 2 of that library. In a statically typed language, that might fail because it might say, hey, even though the type names are the same, they're from different packages. So
yeah, right.
They're probably different.
Yeah, I would claim, right, okay.
But that's only the case if they're unique types. So if you're using more generalized things, like it's, let's say it's just an array of bytes, and it's somehow interpreted differently in version 1 and 2.
Yeah.
Right? The type system is not going to catch that.
Right.
But it might fail silently at runtime, or it's
right. I have version 1 here, and I serialize to a string, and I hand it to a version. He serializes in bars.
Right, and so I've been kind of messing with this today, and I've kind of now reaching the conclusion that it's, even though you get dependency problems, it's probably better to not allow multiple major versions of the same library, because that also solves this issue of having to stick versions in your imports. But I'm kind of curious what the opinions on that are, because I've dealt with plenty of dependency hell issues, and they are annoying.
Yeah.
But they're also not, like, if the libraries are well maintained and there's this problem where, somewhere down the pipeline, some update is incompatible, usually they follow pretty quickly in updating. So you wait a couple of days or a week or something, and then you're good to go. It's not like we have to spend 6 months rewriting everything.
Native mobile app is dependency nightmare mess. And it was React Native was updating fairly frequently, and they depended on versions of things that were not updating so frequently. And I had other unrelated dependencies because I was also heavy doing Bluetooth things. So I need Bluetooth libraries and a bunch of other libraries. And getting a stable set of dependencies that didn't fall over was just a nightmare. So I routinely, when anybody changed, everybody changed, and I bobbled around for usually 1 to 2 weeks before I got stable. And then I would lock them all down, and that would be good for like 4 or 5 months. And then I had to change somebody, and then everybody had to change again. It was weeks more to get it stable again. Yeah.
Right. I think one thing worth adding there, I do believe, and this is, again, it's not something you can really enforce, I think, comes down to goodwill. I would argue that when a package bumps one of its dependencies major version, they should also bump their own major version. I think that alone would solve a lot of these headaches.
It would. And also,
but this is depending on people doing the right thing, and they usually
version
don't.
numbers on those really big common popular Apache org commons or whatever would just be scrolling up as a nightmare speed.
Or you have libraries which haven't upgraded to another major version for ages.
Yeah.
That constantly broke stuff.
Some core piece that's really old, and the owner has wandered off and done something else with his life. Yeah.
The one thing I'm wondering is that you said that you don't want to implement all the set solver stuff.
Yeah.
So the alternative for me that's really upfront, I'd say, is take an existing set solver library. And
no, that's not the issue. The issue is Why do I
sorry.
depend on this or that? Or why am I getting this version number? You want an understandable set of dependencies so you can figure out yourself what the hell happened here. Stat solver gives you a magic answer, but why that answer is correct and why no other answer works is not obvious. Whereas if you had some sort of tree-like dependency thing, where you did the min-max across a tree, you get a clue as to what the answer is.
Yeah, I mean, if your language's main innovation is in package management, sure, but I'm wondering if that's like opening a whole new battlefield of complexity. Nobody is
I think
particularly
that battlefield is
invested
ongoing and is not in any way stable or set. Certainly in the JavaScript realm, the battle is ongoing and wildly crazy.
Yeah,
No, I think it's worth adding there. It's not so much that I don't want to implement it myself, because I don't, and I don't have that knowledge. But it's also that, at least last time I checked there, in this case, my compiler being written in Rust, and also the package manager, I wasn't able to find any libraries that seemed suitable. I think I found one library that did it, but it had very poor documentation. I had no clue to use it, and it was like, I don't know, 10 million lines of code.
all right.
And as part of this language, I am trying to keep my dependencies as few as possible, mostly so I can exert more control over it and make it easier to compile on different platforms and not run in this case where it's like, all my code works, but this dependency 5 layers down the stack. Because that is a bit of an issue with Rust right now. It's not as bad as NPM, where you install something and it installs like 500 packages.
Oh, 3,000 as of
or something like that,
now.
and most of them are like 5-line functions. But there are cases where certain libraries I know, like, okay, if I add this dependency, it's going to add like 15 others. And usually they're fair. Like if you add this libraries for TLS and SSL, and they come with some extra dependencies, like a dependency for web PKI and some sort of common crypto library, things like that. So that kind of makes sense. But I am trying to keep it as minimal as possible, just so I don't have to deal with whatever shit goes on in these dependencies. Now, if a sat solver probably doesn't need dependencies, but it is still this sort of black box, if you will. Like a bunch of versions go in, magic happens, and something comes out.
And some version.
So here would be my approach to that, and I think it comes down to how you actually import modules, or how do you reference the modules? Because if you have something like aliasing, just give people the chance to say, hey, I want that version under that alias and the other version. But it depends on how you reference them, right?
Right. So in my case, the setup that I have that's sort of stable is modules exist in the file system. You import them sort of using like the same structure basically. The import syntax is not necessarily tied to file systems. So specifically, import and then identifier : identifier : etc. Kind of like Rust. Whether you use colons, dots, doesn't matter, but I use colons.
So do you have some kind of dependency file to map those names to actual locations where you're going to find stuff, whether that's a file system, a database, or the web?
So the compiler has a list of search directories or include directories, whatever you like to call them. The first one is the standard library. The second one will be your local source directory. And then the idea I had in mind is for third-party dependencies. Somewhat similar to Node, you would have a directory created in your project. I just call it dep. And the dependencies are copied into that, but crucially, only the code you actually need for building. So not readmes, test, all that shit. So it stays fairly small. And then what you can do is add that directory to the search path. And it would, the structure will match your import. So if I do something like import HTTP : whatever, it would look for essentially HTTP / whatever .inco in one of these paths. The idea there being that I want to keep package management and compiling separate. So the compiler should just have understanding of a bunch of directories that have files that it searches in a particular order. But who or what populates those directories, that it doesn't care. The benefit being there, if somebody at some point finds out, hey, the standard package manager doesn't work, they can use this other thing. It also makes offline building easier, because if I have the dependency, I can just run my build and I don't have to give like some offline flag to tell it not to go to the internet. It makes moving it around easier.
For me, learned long ago, you should only default build without touching the interwebs.
Right. But so the problem is all these, if you look at, for example, Rust with cargo, but it's the same with Ruby with bundler, Yarn and NPM with Node. They mix basically build tool, compiler, and package manager. And so when in Rust, for example, you do cargo build, it'll actually check like, hey, do we have all the dependencies? No, go to the internet, fetch them. And from what I recall, even though it has an offline flag, there are like edge cases, I believe, where it still tries to go to the internet. So my approach is I'm gonna
the Atlantic,
right
with the 1 byte a second. Yeah.
I've had that case where I'm like on the plane, like I want to build stuff. It's like, no, you didn't install this thing before you went on the plane, so screw you. So I wanted to keep that separate such that you can run some command to basically pull in all the dependencies you need into your project, and from that point on, no internet required. You can move it somewhere else. You can bundle it all up if you want to.
Doesn't IV2 emulate this? Because if first time it downloads all your dependencies, but then they became local, they being copied to your directory, and be it you go to the internet, but it downloads from your local directory. But
but so then you need support for that in your package manager. So the idea is basically you have a sort of global wide cache. That's where it installs it initially.
Yeah.
And then and then it sort of copies those into your projects. That way, if I have 10 projects using the same library, I only need to download them once.
Yeah.
Is it using like soft links or hard links?
For now, it would just copy them, but in theory, you could use symbolic links at some point.
But these have to be two separate things. One are the dependencies, two, how you get them.
So they are. How I'm getting them is just going to be pulling them basically from GitHub, GitLab.
You can say it's only local file, or mix and match internet local file, wherever you find them.
For now, I'm going to stick with just pull it from the web and not have support for like being able to override dependencies with local repository, just because the language is so young, I don't need it now. But you also get these complex questions like, if I depend on version blah, package blah, version something, somebody else, even my dependency graph depends on that same package, maybe different version, but a compatible one. And then I say, replace that dependency with this local copy. Does that apply to my project only, or also that sub-dependency? Right? If you want it to be isolated, you essentially need to sort of build every dependency in isolation so that you can have all these local overrides and God knows what, and then bundle it all together. This is essentially what Rust does. Like you can have multiple major versions of packages because it essentially treats every package as sort of a separate compilation unit. And then it does voodoo to like squash it all together and whatnot.
I see you've got a new dependency, Aaron.
It's still the minor version.
Yes, my dependency management has led to a new dependency a few weeks ago.
Congratulations.
That's the newest member of the Coffee Compiler Club.
No coffee for this one yet.
No. Oh, congrats.
Yeah, so I think at the end it's
I don't know if he'll get to coffee or compilers first.
Well, it depends on you. What is his name?
You got a name? You can't reach the mute button, hands full.
Oh. His or her, I don't know.
Don't worry about it.
No.
Caleb Dan Goldman.
Caleb. Welcome, Caleb, to Coffee Compiler Club.
Yeah, Caleb's giving his own welcome.
The thing I'm
Go ahead, Sam.
The thing I'm wondering is this split between package manager and compiler, is it really worth it? I mean, in the end, the ecosystems with competing package managers don't seem to be much better in dependency management than the languages that don't have competing package managers. And in a way, it feels like that should really be the responsibility of the core language team. I mean, the feels like the times where the language team could say, well, we build a compiler, we don't care where the H and C and CPP files come from. I think that's pretty over, isn't it?
No, so it's not so much that I want to actually like support multiple package manager. I don't. Like this would be very much the package manager. It's more a so right now, because my language is still interpreted, the executable is both compiler and interpreter. And so if I stick a package manager in that, all the dependencies that we need would also be part of that executable. This won't be a thing forever because I do want to move towards a compiled language. But from a maintenance perspective, I like keeping it separate because a package manager has things like it needs to go to the internet, which means it needs SSL, which is like immediately a bunch of extra dependencies.
You're planning to ship your language with a standard library, right?
Yes.
So can the package manager that ships with the compiler just be, oh, package fetch is one of the libraries that's in the standard library that is hard-coded to go to your site?
So I probably don't have plans to do like self-hosting either compilers or package managers for a very long time. I had this idea for the compiler for a while, but it's just a lot of effort that I feel kind of makes sense if you like, sorry, 10 years into your language, you have people using it. So there's not like that much to do, quotes. But at this stage, I think it's a bit of a lost cause. But I could see at some point the case being that the package manager is written in the language itself, for example. It's really just more sort of separating the concerns and not having to add extra dependencies to my main executable. And less about, oh, I want competing package managers, because I don't. I think the moment another one pops up and it becomes popular, it's time to start thinking, okay, what did we do wrong? Because I do very much feel like there should be, you know, one ring to rule them all, basically.
You only need one CPAN.
Yeah, essentially, I don't want mini CPAN and CPAN and God knows what.
Going off on a tangent there, you mentioned self-hosting maybe in 10 years. I'm wondering what's the position of the group in general on self-hosting. I've kind of ended up in a place where I say self-hosting is a cool party trick, but why even bother with it? What's the position of you guys?
So what would be self-hosting to you? Not using something like Apache to host your repositories?
No, he referring to write your compiler in your language itself.
Oh, sorry. I thought we
yet.
were still by package.
No, with
Right.
slightly
Okay.
transition.
Yeah. Self-hosting in the language.
Yeah, I think it comes down to your community. I think that there was some limitation on who was willing to contribute to the JVM because there were a lot of Java developers who thought deeply in Java and were terrified of pointers or allocating and freeing memory. So they wouldn't ever contribute to the JVM. So I think there's a balance there of like, it's fine for the core of your language to be in something like C, but the more of your language you can push into the standard library and written in your language, the more the community who likes writing in your language will contribute to the platform itself.
Yeah, that's on one hand, but my stance is that self-hosting compiler is at some point it's necessary because it sets as a boundary between the old language you implemented your language in your new language, and that's the how should I say it? Somehow it sets the new beginning for your language. It sets a new age. It doesn't mix with the old language. That you won't see. Probably you will not see most of the languages posted on GitHub before they become self-hosting, because they don't want to mix the old language with their new language, and it becomes your new thing, your new age of development.
But
I'm sorry.
I think
short,
Cliff was
easy-
first.
Yeah, I'm just old school on that front. I'm intending to self-host eventually, but I understand the mindset of people who do not wish to do that, who happy to build on C or happy to build on Java. Totally makes sense.
Yeah.
So,
I'm
so
wondering.
my question would be, go ahead.
Sorry. I'm wondering about Theodore's notion of old language. I mean, okay, I'm buying it for like C and C++, but
No old as old. The old language you use to implement your new language. That in that sense, not old in age old.
yeah, I mean, yeah, okay. I mean, if I'm implementing my compiler in Rust, I'm not expecting that language to ever get old with like a 6-week release cycle. I'm probably don't have to worry much
What's
about
Rust implemented in?
it's implemented
The
in
first
Rust.
version,
Rust itself.
or Camel. No, the first versions of Rust are OCaml based.
Yeah, okay. So they bootstrapped in OCaml and then they switched over to Rust. Yeah, I mean,
Yeah.
that's totally
Yeah.
reasonable.
I think it's worth adding there. I recall that the bootstrapping process of Rust is quite annoying. Like, I believe I think it might have been Nix. They tried to do that because they want reproducible builds and not rely on some blob provided somewhere. And it was gotten to a point where people are now writing I think it's an alternative compiler in C to like compile Rust, to compile Rust's own compiler, but it doesn't do all the borrow checking, etc. So that they can bootstrap it without having to go back, 10 years and start off with this OCaml compiler and then work their way up.
Yeah,
But you
that's
think
another point. That's another point for you have too many moving things essentially before you become self-hosting, and you have to try to keep balancing all the things. But if you have a new language and implement your language in your new language, and then this process of bootstrapping becomes obsolete.
I would put the question out: did Java have any advantages or disadvantages for being mostly C for so long, except for the standard library?
There wasn't any option forever and a day, so you had to implement in C. Then we did a bunch of things in C where we bypassed the C language and just understood the machine directly and the machine model of C directly, like stack crawling, your own stack, that were not going to happen in Java any better than in C, because again, you have to break the security model and claim you know what the hell you're doing, and you understand how the model translates to the machine code and the hardware, and that varies from hardware to hardware, and it varies from compiler to compiler and whatever, and then you crawl your own stack. So the whole notions of self-hosting a Java thing, the guys who started to do that or tried to do that, they basically switched to a Java minus. And no, seriously, it's very, very low end version of Java. And then they also had places where they specifically broke the Java security model and said, and here we're doing, it looks like Java syntax, but we know it's a hardware mapping of a struct to a hardware stack frame layout kind of thing, right? And that was necessary so they could do shit like stack crawls. So it's not Java anymore when you go down to that point. Now,
the PyPy project did something similar. They came up with the language RPython, which was the restricted subset of Python that they knew they could statically compile all the way down.
Yeah,
which
right.
was valid Python syntax, and the Python interpreter would eat it, but they also could turn it to x86.
They knew exactly what it's going to do. And then from there, that version can then build the greater version, but you can't get away from the restricted version in that sense. If you're going to self-host, always you have a restricted version in there.
In the end, you want to have you need some syntax for your portable assembly, be it C or some Java lookalike or some Python lookalike.
Yeah, right. Right.
Yeah, I think when you install Go from source, it still does some bootstrapping first, a really old Go version, which is probably still in C, and it's going to be compiled, and that compiles the new version of Go.
Yeah, right. So they didn't get away from C as their bottom layer. And
Yeah,
I know
I
some
don't
of these
think so.
folks do get away from C as their bottom layer, but it's, yeah, it's hard.
But for sure, the self-hosting shouldn't be your first concern. It should be thought of when you feel ready to do.
It's not a first concern, but if you put it kind of early, self-hosting puts a large stress on a language in a lot of ways that are well understood how you fix.
Yeah.
So you get a chance to have to deal with a bunch of issues that you're going to deal with anyhow, but they come right in your face right away, and you have total control over what's going on. So it's a lot easier to deal with them right then, right there.
You will exercise a large portion of the language writing the language itself.
Yeah.
But isn't that a bit like the premature optimization? I mean, it's always the danger if your compiler is the largest program written in your language, that your language is very good at writing compilers and very poor at everything else.
Maybe. It's the case that all the first languages and all the self-hosting languages are very good at writing compilers. It's true.
The
But
compiler
that doesn't mean
is,
they're bad at everything else.
yeah, the compiler is such a beast. Then you have to invent and write most of the things you will write anyway in a language, and you just test it on the most critical structure in your language.
Yeah.
I mean, yes and no. It tends to push you towards I have a very good computational model, but not necessarily a very good state management model. Like compilers have different problems than like a video game that's taking events from a mouse and keyboard and trying to respond to them in a timely fashion and get pixels onto the screen.
Well, that's async coding, and I would claim that a compiler is, yeah, I'm with you. It is not async in any way. But that many languages are not async directly. Java's not async directly. People add libraries to help it, but async was not any part of its original thinking.
Right, but I wonder if those time interaction models in our older languages would have been stronger if you had started with, let's build systems that interact with the real world rather than let's build systems that can compile themselves. The Erlang VM was not interested in being self-hosted initially. It was interested in taking lots of events from lots of places and dealing with them.
And that's my point. You shouldn't concern primarily for self-hosting. It should be an afterthought. It should be in process, not I have to build my language in my language and then go and find a niche for my language.
I think it also depends a lot on which language you're using for an implementation and which language, which kind of language you're building. I mean, if you're building your runtime in Rust and your language you're building is some scripting language, you're probably less interested in self-hosting than saying, okay, I'm writing the new Rust replacement in Rust, and as soon as my Rust replacement is ready, I'm replacing my Rust compiler with my Rust replacement language.
I think to add there, if there's sort of two paths you can take to self-hosting. You can, rewrite your stack in your own language and then just say, yeah, we're not going to care about bootstrapping. Package managers can figure that out. We'll just use our previously compiled version. I think in that case, it's not too much hassle for you, but you're putting the pressure on people who want reproducible builds, and that is becoming a more popular thing. And the alternative is that you essentially have to maintain two compilers, where one is a subset of your language capable of compiling your compiler.
Yeah.
And the other one is the full one. Now, I thought about that, but you end up with these really, you have to be really almost religious about forward compatibility.
Yeah.
So if I add a keyword to my language, the way to do that is you first have to add it to both your compiler and your bootstrapping compiler, release a new version, and then somehow in your documentation say, hey, starting this version, you have to use at least these versions for the compilers. Then you can use it in a separate release that, and that you have to sort of repeat every time you make a change that that basically requires forward compatibility. Now, backwards compatibility is already difficult enough. Forward compatibility, I don't think people will be able to deal with that.
So I was
Like
thinking
maybe
about-
unless your name is like, Rob Pike and Ken Thompson or something like that, but
thinking about your comments about what languages are used for what and when. Rolling the clock back 40 years ago, you absolutely needed the language self-host because that was such a nightmare to build. Going back 20 years, you didn't necessarily need the language to self-host because C was reasonable, but you desperately wanted a new language with new features. Now maybe I'm old school. I think I want to see self-hosting. That being said, I totally get, you don't need to do it. It's totally fine. And if your focus is on async computation, you need to get a fucking threading model worked out. And Java did that in the most general way so that it could be used in many places where you do multi-threaded computations, like all kind of web servers and database interactions and the like. But it didn't focus on async for a GUI interaction. So maybe there's something better to be done there. That's the whole async await or some variant thereof. But that's it's a whole language focus, not whole language. I'm sorry, so that's the right word. It's a serious language focus to do async await in a way that's useful and productive and understandable and usable and all that kind of shit. And that is orthogonal to self-hosting. And with that being said, and we all stopped talking, has anyone seen a good async await coding model for doing user interfaces?
So ironically, one of the first languages I ever wrote in, I thought had a pretty good evented model. I started in Visual Basic, writing plugin features for Word. And it was
Really?
like, oh, drag a button on here and double click it, and suddenly you're in Visual Studio and they've already written the frame around it that's like on event. Here's your event. I'm going to hand it to you and deal with that. And
Oh,
I
interesting.
think that because this language was essentially written with the goal of making it easy to write Solitaire and Minesweeper, it was pretty good to get events from a keyboard and mouse and put pixels on the screen. And a lot of the languages that are even more modern, it would be much harder to write Minesweeper in Rust than it was to write Minesweeper in Visual Basic.
I think the only surviving languages that keep this rapid application development things are like Delphi and the whole Borland suite, where I'm not even sure.
Delphi is
how
related
the
to C#
company-
in some way, right?
I think the designer came from Borland. But apart from that,
I think Delphi is more inspired by Pascal and that sort of chain of languages.
yeah.
But it is one of those languages like Visual Basic where they have still to date, I don't know in terms of aesthetics, but it has a pretty solid sort of GUI libraries and things like that.
Yeah, then what I just mentioned was that the person who did Pascal later went to Microsoft and did C# as Anders Heilsberg. But I mean, I think this convenient UI model is pretty much dead at the moment.
I used Elm for a couple different GUI interfaces, but it definitely was not a point and click. It gave you a solid, reliable, provable, good async interaction and HTML. And the combo is, it was reasonable. But, you wanted a button, you just said, button of the following parameter. You wrote it all out. You didn't get to click a button on a screen or drag and drop or anything.
I mean, back in the day, Swing and Tickle TK,
Oh, yeah.
felt like I could get stuff on the screen. Whereas
Right.
today, I feel like you really fight if you try to do your UIs in HTML, and canvas tags not really better.
Maybe that's That's a good language focus then, is to make sure you can do a reasonable 2D screen layout.
I mean,
Interactions.
but actually, you know, if you come out with a new language and I can say, hey, here's my demo, I can play a tone to the speaker and draw a pixel to the screen and receive a mouse click.
Yeah.
Like,
yeah.
I was writing Python for a long time before the first time I wrote a line of Python code that reacted to a mouse click.
Yes. Okay. Fair enough. That puts, language thinking in the start. Well, it puts multi-threaded thinking in the start. Multi-threading shit, unfortunately, goes right to the core of the language implementation. And that has to be thought in early on. And, all right, fine.
Well, is it necessarily multi-threaded or just evented IO?
Well, so there's a model of the universe that says I have one core running and it's eventing and it's switching between tasks, basically. And then there's no multi-threading issues, and you throw away, 90% of your CPU and your box because that's what you're willing to do with that model. And then there's a version that says, hell, I want to do, parallel data mining management, or I want to run my JDBC driver in conjunction with everything else. And I absolutely want to have 20, database queries running at the same time. And you really need to have multi-threading, not asynchronous IO. The Erlang has it, right? So a lot of folks do this as agents, and Cameron's not here, but he does it too. It's the same thing as the services, right? So there's some multi-threaded thinking going in, but the implementation of that multi-threaded thinking goes to the core of what you're doing. And so it goes into the bootstrap of the self-hosting compiler directly. Like, you don't get that shit out of C, you get it out of C libraries and a lot of careful writing of C code where for a fact you're doing shared memory, but you don't get any C help for that shared memory update shit. Maybe atomics are reasonable now, maybe they're not. Certainly, when we did hotspot, there weren't no volatile did shit for you, like really nothing at all. It was like a throwaway keyword. So you just had to hand manage that. So if you want a language who's got reasonable memory coherency things for multi-threading going on, you have to put that in the core. And that goes right into the bootstrapping the compiler, love it or hate it. Because you have to have a language internally that says, and here I have two threads that are talking to each other and they're independent, and how do I manage that? And the Erlang model is I write bits into a buffer and I hand the pointer to the other guy who reads bits out, or I serialize them somehow and I deserialize them in the high semantic, but the optimizer and the compiler conspire that it turns into some sort of, I handed a shared memory pointer with memory fencing between writes between parts and went back and forth. I think Cameron's got it a little better thought out, but Erlang has a reasonable model, and that disallows certain other kinds of reasonable models. And you make a decision right away in your core library that you can't have a large shared memory cache if you do it the way Erlang and Cameron doing. Erlang fixed that by having a large shared memory cache as a single large shared memory as a thing that's part of the language. There exists this shared memory database. I don't know why I necessarily want that in my language, but
yeah, I was going to say, do you have a mental model of what you want AA to do with, like, the operating system would like to raise to you that an event has happened? Mouse click, keyboard press, network packet arrived.
Yeah. So events that are going to come from an event model that a user thinks about in that way are probably going to go somewhere down the line of what Elm does with, there's a thread that we agree on that's handling events, and we know that this thread will handle them one at a time. And because it's handling one at a time, there's no synchronous or asynchronous things. And because it's handling one at a time, there's a throughput limitation of how fast you handle events.
So if I want to print a standard out, I have to hand it to the standard out thread.
Yeah, right. Or there's some throughput limitation. How fast can I pull from a shared queue, a non-shared queue? Multiple writers are writing to the queue. That's all your events, wherever they come from. One reader reading from the queue. And then that turns into how fast can that reader read from the queue compared to the 30 threads that are writing to the queue. So, you get an unbalance there. On the other hand, the guy who's reading from the queue and acting doesn't have any multi-threading behaviors going on per se. He's got eventing behaviors which are async await, which are I have partial requests that, I went away and came back on, and, and here's where Elm comes along and says, I free make you a state machine, and you get the state machine benefits, which of your async await behaviors, which gives you, fine-grained slicing of events while you're still writing code that looks like it's sequentially in order. Not quite as clean as you might like, but you get a kind of a reasonable way to go do that. So there's something going on there where I want to say, here's some straight line code with breakpoints. Under the hood, I'm going to turn that into a series of events and event points, but it's still going to run single threaded for you to not have to deal. And then there's a version in my head that says, and I still want to do like non-blocking hash map, because I find that's incredibly useful for power throughput production. Also good for people doing JDBC drivers and anyone who's a large shared memory cache. I don't want to implement that as a language feature. I want it to implement it in the language. So then there's a shared memory thing going on. So I haven't sorted out all the right answers here. So the thing that says I kind of want to have, the eventing model is written in the language, not part of the language. And can I make it convenient to write the eventing model and then promptly hand you a library that produces an eventing model handler that does things that do well with browser interactions? And that covers, the first cut of 99% of people who just touching the thing and want to fucking make a dancing baby on the screen, or, write a tic-tac-toe game or Minesweeper.
So to make that a little more concrete, do you have something that you imagine as the like read from a file API for AA that we could drop in the doc? And
no, I don't.
Because I assume you don't want to default that to be the entire thread blocks.
The entire what?
You probably don't want your default way that you read from a file to be block the entire thread.
Oh, no, that's not true. There needs to be a convenient way that says, read from a file and take an event that comes back later with a filled in buffer. But what I think most people do most of the time when they read a file is they expect the file to have been read, and then they carry on. So the default API is like read, and when the read returns, the buffer's full of data. I think that's a good default. There's an asynchronous version of that maybe the default one builds from, and the default build one says, read async.block, to .block till done. But the default one's probably read and block. And then there's a cheap, easy to get at one that says, read and here's an event. And when you block on the event, then it's done.
And I think the important thing is it doesn't really have to block anything as long as it's implemented in a way that you that you can basically just drop it off the thread that is currently running it and do something else in the time.
So suppose it returns you a future buffer, right? As soon as I read from the buffer, now it blocks, and I have to wait for the buffer to fill. But you could have the default API says, I return you a future buffer. And when you ask for the future, you get an error or a buffer. And if you got a buffer, it's fill. But if you don't ask for a while, you can go do other things. You can go ask a bunch of reads in a row on futures. And that's the default model that says everything's a future or whatever. Anything that might block, get you a future back. And you block on them all later.
Yeah, my personal opinion, I think JavaScript got this very backwards. That the async await tends to propagate through my code like crazy.
Yeah.
I want it to be the other way. Most people write most functions to not have an async or await. And if I want something to happen in parallel, I should say the go model, go do this. Now my return got wrapped into a promise. And unless I asked you, no, I want you to go do it asynchronously and stick the result in a promise.
Do you want to see the promising of your results as a thing that you had to say, or you just by nature?
The person who implements the function, I don't want to have to think about promises. I think it should be at my call site where I say, hey, go call this function, but don't do it right now synchronously in a blocking way.
Okay.
Give me a promise back instead. I am doing an asynchronous call. And I think it should be the caller that says, I'm calling in an async way, not the person who wrote the function who says, is this an async function?
Yeah, but I think the difference between JavaScript and Go is that you have multiple threads or you have just single thread, and everything has to be put and basically if you want to implement it into a coroutine or a promise or whatever, right? think that's the problem why JavaScript looks so weird and just goes all the way through.
Because they're not really multi-threaded
Mhm.
in that sense.
Right. Well, not only not really, it is not multi-threaded. You can have worker threads, but their own event loop, right?
Yeah.
I also think that what saves JavaScript is that a lot of the functions you declare as async, you're not really calling them yourself, and you're not really feeling the whole pain. For instance, if you define a component, you have an async connected callback, and if you need something asynchronous in that callback, you throw in async for the function definition, and you don't have to care at all because the runtime does all the calling for you. And I think most other languages don't have that luck.
Well, the problem is you can call an async function only from an async function. So
Yeah, sure.
right? So it goes all the way down. If you write a Node.js application using async, the first thing you do, well, at least in the older version of Node.js, is you wrap your original function, your main function, basically an anonymous function. You call it right away just to get rid of this async stuff, because what else are you gonna do, right? You have to start somewhere.
My opinion for a modern language, everything should be optional or either, and everything should be an async. And a later stage, let's say for a language that can figure out that none of this should be async, everything can be happening in sequence.
It should be the Erlang model. Like you just do your IO, you
Mm.
don't care if it's async or sync. The runtime does it for you.
Yeah,
Isn't
that,
it
Well, what do you do with a read on Erlang?
So
That-
I don't know specifically about Erlang. I believe they use separate. They have like a, if I remember correctly, they have like separate threads where they sort of send messages to, and they do the IO and send it back.
okay, that's
What
it.
I did with Inco, what I
Hmm.
actually recently implemented like a week or two ago, because I used to have two thread pools with fixed sizes, one for running just regular code, and then there was an instruction which would then move the process over to the blocking thread pool, and then you could do your file IO or whatever stuff there's no async equivalent of. I ripped that out because various reasons, but crucially, you end up moving process sort of back and forth between these pools, which means I have to go through scheduling overhead. And so what I recently implemented is an approach kind of similar to Go, where within the VM, these various operations that I know are blocking, they're sort of annotated as blocking. And then when they start, the thread basically sets a flag, does its thing, and then when it's done, it essentially unsets that flag. And in the background, a monitor thread will periodically wake up, examine these threads, and say, hey, is this thread blocking for too long? Yes, we'll wake up a backup thread. That one will take over the work. And then once that blocked thread is finished with its blocking operation, it will reschedule its process and then become a backup thread. So you have these sort of threads swapping out with each other. Unlike Go, I have my thread pools at a fixed size. Go has they have a limit, I think, of 10,000 threads. But when you hit that limit, the program crashes. Because they're like, this is too many threads.
Yeah.
Whereas what I ended up doing is just saying, oh, the backup pool has a fixed number of threads, and if they're all used, the process just sits in the queue until it's picked up. Because I think that's a little easier to wrap your head around and sort of prepare for.
H2O went through all these shenanigans.
Right, and you can still set the pool to like 10,000 if you want to.
Right. I eventually sorted out my issues where I didn't have to have the 10,000 pool, but there was a point where I had a pool set at 10,000, and sure enough, it ran out, and the process deadlocked and hung.
And so, at least in my case, within the language, currently this is done for like sockets. I use non-blocking IO. For like files, spawning sub-process, and a couple of other things, it goes through this sort of blocking mechanism. Now, implementing that was not easy. Various bugs had to be fixed. Some of them only occurred on Windows. They were not specific to Windows, but they happen on Windows.
Yes.
And getting all the atomics and whatever correct is every time I'm reminded why I hate atomics unlocking. But it does now work, and the cost is, I think in the best case, when it sort of flags itself as blocking, it's about 100, 150 nanoseconds. Because in the best case, it's essentially it has to atomically read what I call an epoch, which is just a counter that these monitor thread increments every 100 microseconds in this case. And then the thread has to atomically set it again. In the worst case, it has to push some work away if it has any. But that's, the time will depend on how much work there is. And then the wake up is something similar where it does a atomic swap where it says if the epoch is still the same, that means we finished before we were flagged as being too slow. So we just set it, go on about our business. And if this monitor thread swapped it, then we have to become a backup thread basically. And then the complexities in making sure that this monitor thread doesn't just wake up every 100 microseconds forever, because you end up wasting a lot of cycles. So it has to go to sleep, but I have to make sure also we have to wake it up again if it's in this deep sleep. So that's where all the kind of complexities surface. And then long term, I will probably use IO Uring on Linux to do async file system IO.
Okay,
But
how would you implement your self-hosted language would implement this particular set of features?
so my
Just
very sort of long-term goal
Yeah.
is that my own language, instead of compiling to bytecode, that would compile to machine code, and it would link to my runtime, and that runtime will still be written in Rust. Like I have no plans of writing that in anything else.
Okay.
And that's partially because it depends on things that I don't have in my language, like atomics, shared memory, and I don't want to expose
Yeah,
those.
right. So that's what I was talking about. Your language, self-hosted language compiler, if it's going to be self-hosted, you have to deal with shit like multi-threading.
Right.
And atomics.
Yes. So my runtime would never be self-hosted. The compiler maybe at some point, but no plans for the next
Thread
5-10
creation,
years.
thread scheduling.
Right.
Then you get into priorities because the OS lies about priorities on threads, and there's a bunch of other things going on.
Yeah, I specifically in my model, because in Go you can pin your tasks to an OS thread.
Yeah.
I used to have that. I ripped it out. It introduces some issues with foreign function interfaces because my language can reschedule a process at basically any point in time. So you can run into cases where you call some C function, it sets error no, and then you try to read it, but because you're now on a different thread, you're reading a different value. That I'm not sure yet how to deal with that. I had this model where you could pin it, so it wouldn't do that. But that quite significantly complicates your scheduler.
There's other FFI issues where the FFI has its own internal state.
Yeah, thread local state, GUI libraries that insist on running on the main thread.
Yeah.
For GUI libraries, I kind of said like, well, piss off. Like so first of all, I probably can't support them anyway because they often heavily rely on calling back in your language with callbacks.
Yes.
I don't want to support that because that introduces so many issues.
New issues. Yes.
So
Java,
that
by the way,
basically
fixed that.
immediately rules out like 9 out of 10 GUI libraries.
Java took the hard line to fix that, and they said we tried doing callback. It led to so many bugs. So the JNI interface only hands out handles to GC pointers, never the GC pointer itself. If you peek through the handle, you lose, and we will not support you. And many people immediately took the GC handles and peeked through them and kept crashing and crashing and crashing. And it took like 5 to 10 years before all those libraries finally got rewritten to not peek through the handle, and the GCs that could then independently do concurrent background GC things while the FFI was running, because the FFI guys just kept getting burned when they cheated on it. And that was a hard line to take. It didn't start out that way, and it took a long time to get it straight, but they got it straightened out. And then now you can FFI in Java pretty reasonably, and it's okay.
Yeah, so callbacks, I'm like, no, I'm not going to do that. You can fix your API so you don't need callbacks. I think for GUI libraries in particular, I think it's better to have this sort of evented model where, as a consumer of the library, you pull events out of it instead of having this loop that takes over your thread.
But there are plenty of GUI libraries that fondly believe in callbacks. So yeah.
Right. But so since I can't support them, or at least don't want to, I also was like, okay, those are usually the only libraries that insist on running on the main OS thread. So we can also scrap that idea because that simplifies some other bits.
That does. Yeah, that's a good point. Yeah.
But for the pinning, you have this problem where if you have work stealing in your scheduling algorithm, you have to make sure that you never steal from a pinned thread. You have to
Mhm.
make sure that when you reschedule a process, it's always rescheduled on that pin thread.
Yes.
Mhm.
You have to make sure that when you enter pinning mode, you push all the work away. You don't put new work on the queue.
Mm.
I ended up basically having a schedule where there were like 2 different code paths for every thread. They would say, oh, if you're in blocking mode, or sorry, pin mode,
Pin
you
mode,
have to do
yeah.
this path, otherwise that path.
Yeah, yeah, yeah.
Your queue data structures end up being quite complex because
Okay.
those
Yeah.
pin process go in like a different structure than normally, and
Yeah, yeah.
I got rid of all that. I was like, for
Yeah, I didn't do the
FFI,
pin thing, but I know, I mean, I've watched Java suffer through it and then give up and back off from it. There was pinning for a while in the threads, and then they said, no, not doing it.
yeah, and it's you can also deadlock things. Like if you have, let's say, 8 OS threads, but 16 tasks running on them,
Yes,
8 pin themselves, the other 8 will never run.
yes, yes, yes.
And so I think my long-term goal there is that once I will probably move to machine code, I will also have to change the foreign function interface anyway, because right now I'm using libFFI. At that point, that won't be necessary anymore. And I think what I might do is this case where if you call a C function, right now if you call a method, the scheduler inserts this instruction that says, hey, after we return, we might reschedule. And I might do something like, oh, if you call a C function, just don't insert that instruction, and then tell people, hey, if you need to call these 2 C functions that depend on global variables, call them directly after. Don't call methods in between. That local state, I'm not going to care about because, again, it's too messy to deal with that.
You document it then.
Yeah, and maybe I might have some region where you sort of annotate a region, and then within that it will not reschedule. But even that is kind of difficult because there are various parts in my language where it simply might have to reschedule.
Yeah,
Like
right,
if I
right.
wait for a message to come in, I might not have a choice, right? You can't disable that.
And that kind of reminds me of the list of signal safe or
Yes.
interrupt safe methods or functions that C runtimes usually ship with. And I mean, you wouldn't be alone with that choice if you're doing this.
Yeah.
No, because I think like really only have 2 choices. You either say, if you follow this pattern carefully, it's mostly going to be okay, but you have to think carefully about it. Or we're going to put all this complexity in a scheduler that will affect 100% of the users, but only caters towards like 1% of them. Because fortunately, most C libraries, apart from the errno variable, which you can special case, they generally don't rely on global state anymore. Yeah, there are some exceptions, of course, but most ones I think most people would interact with.
I guess the question is whether in your language you can encode the constraints in a way such that a compiler can verify that your program is correct. So you don't have to rely and pray that people are doing it correctly, like with C.
Boy, I did this both Java in runtime and H2O runtime, and I had to hand manage myself with no compiler support. And sure enough, you got plenty of bugs. You just blew the management of that shit. Oh, yeah, I don't know what the right answer there is.
No, so I'm thinking there, because for C, you generally have cases where it's either they set the global error variable, the threat local error one, or they get full in and they have all this threat local state that they're mutating and doing all sorts of shit with.
Yeah.
That second case, I'm honestly inclined to just say, like, sorry, we're just not the right language for it. Like, tough luck. Now, for the error variable case, that you could special case in your language where you say, call this function and then populate this local variable with the result of that thing.
Yeah, I think that one's easy to do.
Right.
It's the
and I think in all cases, I would be more inclined to take the Java approach of essentially saying, well, just write your shit in the language, like they did with Java. It's like, yes, we have J and I, but you should really just be writing this in Java in the first place.
Yeah, well, there's some shit you have to write in J and I, and the J and I, but it's actually, typically it's really minor. and been done a long time ago. You know, JDBC drivers maybe go there that are not early on. The early on shit was all files, you know, socket interfaces and non-blocking socket interfaces when they showed up, and accept or whatever the damn latest version of epoll or something. And no one else goes to JNI. I think there's some old folks who tried to go to JNI for like BLAS libraries and the like, and I think, yeah, these days, just better off to call Java.
I'm wondering what's the cheapest way to deal with, let's call it threading or async or something, without committing on a certain approach. I feel we have a situation where we basically go around in circles, where we start with threads, then say, well, dealing with threads and passing information between is kind of inconvenient. Now we're doing promises and futures where you have like this generic type, and whenever your thread or future is now done, you get a return value of that type. And later people say, well, all this future stuff is inconvenient. I have to use all the combinators. So then async await is invented, and then async await affects everything. And it seems like the newest approach is what Java did, saying, okay, well, let's just do cheaper threads again. And I wonder how often we will go in this circle before we find an approach that seems to be.
Well, there's an argument made that none of them are truly any better than the other, but the grass always looks greener when you're on one side, you're looking at the other side. And when you finally get to the other side, you realize the grass is pretty green where you left it. And then there's no good answer, you know, maybe.
Yeah, that's what
everything looks good when you're buried in that much complexity.
Yes,
yeah. And that's what I'm wondering. What's the cheapest way to like get our stuff that we want? Because at the moment it seems like languages will go around and round and round, and until they have like all three approaches implemented, and all the future users will have to pay for all the three implementations, and that seems to be
it's because we don't know how to do
weird.
Multi-threaded computing in a way that everyone agrees is how it works. So everyone's trying to look for a different answer.
I think
I really like the well, I'll make my obligatory closure comment that I really like the approach that Closure takes, where you just make all the core data structures immutable, persistent.
Yeah,
you pay like a small performance penalty, you know.
Not small, that's the issue.
It's not too bad. And but then you get multi-threading, you know, with any paradigm you prefer.
The problem is it's actually in many of the cases that we're looking at here, it's huge. It's not small, and it's so huge that it just disallows certain kinds of things that we can solve in other ways that are interesting problems to solve, and so you just can't do it. Here's a data set that's a terabyte, and it just barely fits on my machine. And now I'm going to run my 32-core machine on this terabyte of data and do a bunch of processing on it. What am I doing? Well, I'm doing fintech work, and I'm going to make millions and billions. It's highly motivating. So of course I'm going to do it. And if I whip out Closure, that terabyte blew up to 10, and then it didn't fit, and I can't do it. And so it's just a hard stop. And so there are clearly valuable use cases where you just can't take that much overhead. So
in my experience, the overhead's usually somewhere between 2 and 2.5x of what you could do sort of optimally.
Yeah, I'm thinking that's big enough that it would hard stop kill a lot of things that we're doing right now, and therefore a bunch of people are going to say, nope, not doing that.
I mean, on the one hand, 2.5x is a lot, but hardware's cheap and developers are expensive. So the crossover point
there. Just going to make the same comment. The amount that you spend on 2x the hardware is probably cheaper than 2x the developers and 2x the bugs.
2x the hardware.
I mean, it depends on the size of the data.
Yeah, only if 2x hardware actually works as well, because you don't get 2x faster CPUs. You get 2x more, which doesn't necessarily help you.
Yeah. Yeah. Well, you know, the good thing is that you have this escape route, right? So in the little bit where you want it to be cache coherent and super fast, which you're not going to do with your whole multi-terabyte data set, you can you
hang
can
on, H2O here.
escape that, right?
So exactly H2O. That's what it was.
Mm.
It was coherent and it was multi-terabyte and it was a lot more than 2x in general. A lot more than 2x. So 10x was common. So it was a big speed gain. Now the problem sets were different. It was you had to have some sort of large data set. You're doing something semi-embarrassingly parallel in the first place, but the speed up factors were very large there. And then as soon as you go to GPUs, the speed up factors go, another 100x over H2O. So there's big numbers to be had, and there are definitely people who are excited to see those bigger numbers. I'm not saying Clojure's not bad. I'm just saying it's not it didn't solve an entire industry worth of data science problems.
Yeah, well, that's true, but I think there's no one solution for all. So
and now
to
we're
add-
putting out.
to
This
add-
is exactly the conversation we're kind of coming around to. What's the writing answer?
Yeah, I think this is some of the OLTP versus OLAP debate that databases have had forever, is that the online transaction processing systems just need different things than the heavy data analysis workloads.
Maybe so.
You
And
just
now what
need a
H2O
model.
wants to do here.
So I think the first step towards that will be to make sure that OS threads are much cheaper to spawn.
Yeah.
'Cause in my case, for example, I've really been wanting to tie my lightweight task to OS threads because it makes the FFI easier. It makes this, like, I wouldn't need the scheduler code. Just let the kernel do it.
Yeah, did you see the recent announcement that spawning processors now gets 50% price off on Linux?
No, I
Yeah.
do know that Google has been in recent years. They had these patches since 10 years to make spawning threads cheaper. They call it like user threads or something like that. And this started in 2013, but only 2-3 years ago did they start contributing them back to the Linux kernel. And I just remembered because there were some strong words exchanged on the mailing list, where the author was like, "Oh, we have this, this video of it here. You can check out this presentation." And somebody of the Linux developer said, basically, you can go £. You have to explain it here. I don't know what has happened since, but at this point, I think spawning a thread on Linux is about 20 microseconds, 15 in the best case. I've seen it go up to half a second in the worst. That needs to be fixed. That needs to be like a microsecond at most.
The recent news is that people behind IO Microring and I think also some Rust people are involved have announced that they are working on an API that basically works like IO Microring, but spawns threads. So it does away with all the POSIX and Linux legacy stuff, and I think it's twice as fast as the next closest variant. I'm just trying to look it up. I have trouble finding it.
So this like directly comes to, for me, it comes to the question of, should AA support, whatever we call it, green threads, user threads, tasks versus threads, fibers, or just go to OS threads and hope that they stay reasonably cheap. This seems to be a thing that we were just talking about. It bounces back and forth between how expensive and how cheap it is and how we love it and how we hate it.
So I did sort of benchmark this like a year ago, maybe a bit more, where at some point I changed my scheduler to use one OS thread per process. Now it was fairly dumb. It didn't recycle those threads anyway. It's just spawn task, spawn thread, task done, kill thread. And I think with my test suite, it was quite considerably slower. My test suite at that time didn't have that many tests, and it only ran, I think, like 8 threads in parallel or something. But it was substantial enough that I was like, okay, shit, this is not a cost I'm willing to sort of gamble on that it's going to get better or good enough in the next 5 to 10 years. And then you have also the problem that on macOS, I think a OS process is limited to about 1,500 OS threads, after which it will just crash. I don't know what the limit is on Windows, if any at all. But I do believe the cost of spawning a thread on Windows is more expensive. So you have to not only decide, am I okay with depending on OS threads, but also say, am I okay with basically the performance differing greatly between platforms? And essentially, what is my production platform that I want to target the most?
That was one of the, Hotspot went down that path too. We had Windows APIs and we had Linux and Mac, and then we had to argue performance differences between them, and we just sucked things in. Somebody gave us fair thread priorities, for instance, fair scheduling, but Linux did not. So we ended up doing fair scheduling ourselves.
I think there's something to be said for putting the concurrency model in the standard library. I look at applications like Photoshop, where you start Photoshop and it spits off 1,000 threads that are mostly relevant to features that you're not actually using right now, because there's no good way to have a small thread pool. Whereas in a Go program that may have 10,000 Go routines in it, there's only 8 threads that are running and scheduling all the things, because Go really said, look, if you need to do concurrent things, here is our standard library. We're going to set up one thread pool, and we're going to put you all in this thread pool, and we're not going to end up with this. Feature A has a thread pool of 8 threads, and feature B has a thread pool of 8 threads, and feature C has a thread pool of 8 threads.
Instead you end up on my multi-processor desktop machine, application 1 has a thread pool, and application 2 has a thread pool, and application 3 has a thread pool, and they all fight. But it's better. Okay, fine. You move it up to the application layer where they have communication about resources that may or may not be available.
I mean, yes, you want that to get closer to the CPU. If I can replace my many thread pools per module of my application to thread pools per application to thread pools per operating system to thread pools in the hypervisor, so there's really just one thread pool.
Yeah, we have.
The CPU is pretty good at making sure it's got some number of threads and not changing that, though.
Yeah. Okay. There was like a priority thing going on where like people had high and low priority threads on the JVM, and that went to high and low priority threads on the kernel, which was dictated by the OS, is what that actually meant. And so the MySQL running next to your Java application with its high priority threads were taking the high priority threads that you're reserving for your GUI, and you wanted the GUI to be responsive, but GUI couldn't ask for a higher priority than MySQL, and so MySQL just ate you up, and now you're just stuck. And that was every possible application landed on the box and ran. You couldn't actually say, give me a box-wide high priority thread resource, or negotiate with all these other processes, and I claim I should be higher priority. Now that's a missing thing for everybody, though. There's arguing between multiple competing consumers of resources for scarce resources. There's no publicly well understood API that all applications adhere to that says, here's how I negotiate. I actually mean high priority or I don't. Like I'm running a thread that's doing GUI updates. Okay, I'm running a thread that's doing non-blocking garbage collection, and if I don't get CPU time, I'll block. And then the application I made a promise to is that I won't block for you, and he's trying to handle network packets to do trading algorithms, which is the higher priority, and why, and who negotiates.
Yeah, I almost want that built into my OS's spawn call, so I can run an application that is going to start the whole application. And that thing can say, okay, start the database, it's on a core, start the thing that's doing the actual web serving, it's on a core. These two things are never allowed to be on the same core. The database is on core A, the web server is on core B, never the twain should meet. Stop messing with each other.
Some sort of priority thing that says we all get the priorities we agree on. Like suppose I keep using trading, but suppose it's just avionics. It's a hard real-time flight. Suppose it's fucking Tesla and a self-driving car, right? All of these things have this priority issue with who gets it. If you have a limited CPU resource and I'm doing a plane and I have a GUI display, maybe I want to keep the plane level and the pilot's display gets a little herky-jerky during something, and he would like to see the flight, but he's got a millisecond reaction time in his own brain. So the fact that he got paused a few micros on his display, maybe he doesn't care. But you get that backwards and, plane doesn't go, or the Tesla drives off the road or runs over a little old lady. We've already seen Tesla run over a little old lady.
Yeah, sometimes I really care about real time. If you can set off my airbag in a microsecond instead of a millisecond, that means nothing to me. But if the tail latency is a second, that's a problem.
Yeah, yeah, but the tail light can be microseconds, and now I want to say, yeah, how do I even say this thing? Yeah, give this behavior with a reaction time of plus or minus, or here's a Gaussian bell curve or something. I don't have any way to say that.
Oh yeah, this is your airbag. You've got 15 milliseconds. Do not exceed that limit. The
Yeah,
airbag
right.
needs
Yeah,
to
yeah,
go
yeah.
off. It needs to go off.
Yeah. Actually, I think airbags have it tighter than milliseconds. I think they're actually in micros. The numbers are pretty ugly. Whereas the drive off the road is probably actually in millis. That might be in there. Fine. All right. We've agreed that we don't have a common solution for handle multi-threaded async bulk throughput versus whatever, and it's promises or it's lighter weight OS threads, which are still clearly not as lightweight as like fibers or fork join tasks. I use fork join pool because that's what was available, but that was overhead for switching a task was a CAS instruction.
And the first step in that direction, the language should allow seamlessly to move from a synchronous call to asynchronous call, and that asynchronous can be managed however you want: threads, no threads, fibers, and whatever. Most of the languages.
Somebody says at the call site, this call is asynchronous.
Mm-hmm.
The obvious one being you have an async call, it takes a function pointer.
Mm-hmm.
And that's going to hand you back the promise.
Mm-hmm.
I dropped a code block of what I was thinking a little bit lower down.
Yeah, anonymous function. So that's a code block, whatever.
Mm-hmm.
But I wrapped it and I run this async. And I got back the promise. Oh, here's the other piece of that one, by the way.
Yeah, so this is an actual async but most of the
Cliff, if you scroll down in the doc, what do you think of that API idea?
The async taking an anonymous function? I'm sorry.
It just takes a function.
Yeah, it takes a function, an anonymous function. But whatever. Yeah, it's because I think that's reasonable. I think I don't know until you code these things in error, it's hard to say. In anger, until you code them in anger, it's hard to say. I will say there's a missing piece here that I ran into H2O. It's easy enough, and that's gather the promises and then into a bulk promise in some super efficient way. So I can launch 1 million promises and just gather the 1 million promises. And I don't have to hand manage 1 million promises. I just have a
That's the second thing, how you group asynchronous work together in order to make it cheaper.
This is me saying start grouping the asynchronous things together. And then there's a bulk weight. And when I did H2O and I had a million, I had 10,000 cores and I wanted all 10,000 to be done across the cluster. I had a single wait point and I could efficiently actually, and they also internally spawned and completed tasks, every few millis anyhow. So I was getting thousands or tens of thousands a second. I had a single wait point that would gather tens of thousands a second of pending futures, most of which would complete in a timely fashion. And then had a single block call, and that turned out to be a very handy IO for dealing with scatter gather of large counts of asynchronous tasks.
The question I have when I see the code example is this file.read is synchronous in the first example and async in the second call. Does this mean that file.read has 2 implementations, one for the synchronous version and one for the async version, or?
No, I'm hoping that sys.lazy can wrap it.
Yeah.
Sys.lazy says put this task on a work list somewhere, and when it's done, update the promise.
Yeah,
like this
I like
stream.
That's what I was thinking of. You passed the async call, you passed the function into the async call. Oh, I see. Oh, come back.
The problem I see with this is that we are basically inventing some kind of thread or task or whatever to hold the computation at a time where basically the Linux API with IO microring marches toward a world where we don't need to spawn threads to do asynchronous. processing, and
Wait,
I'm
wait.
wondering
with
when we're indiscriminately wrapping operations in
I don't understand.
promise
Right, but
of
I still need something in my
words.
syntax to say, don't wait for the async call to come back. Start executing the next line of code immediately after this work is queued.
There's nothing have
I
to, there is no threads yet, I believe here, because
No, in the code that we're looking at here, right, is this, the future date equals sys.lazy. I claim that as soon as you said sys.lazy, you may get a thread in a thread pool.
I mean
But
that's
that's a unit of work. This can be equalized to anything
And for,
asynchronous.
Aaron's thing, that the syntax for AA would be to put curlies like that, because curlies with no arrow is a function with no arguments that just thunks the file.read call straight up. And that's your anonymous function.
Yes, that's true. Sys.lazy needs to call it later. So I have to do something to stop it from evaluating in
Yeah,
place.
right.
That will return a thunk, and every time you call it, it will read a 496 bytes.
Well,
Every time you call it.
Yeah, yes, it's a thunk that does a file read of 490. Yeah. Yep. And then future data should have a flag bit for done, and it should have a block me now call. Block until the done is set. Ooh, somebody's hacking something here. Yeah. Yeah, because this will be a version of lazy that takes a function.
Yeah, so
and
there's two ways to
arguments.
do it. I can do it where I pass in a thunk and there's no arguments, or I could say I pass in a function pointer of some kind and then a list of arguments.
List of arguments, yeah. I claim the type safety on the first one is a lot easier to deal with.
Mhm.
The second one's going to take an arbitrary function, an arbitrary list of arguments, and now
And allows you
function
to control the call, how much you're reading on each call. Maybe.
Your argument is the second one's not actually any more general because
Yeah.
whatever arguments you were going to pass in just get closed over by
Yeah, but can you change your decision later for, let's say, to 1K bytes later?
Yeah, right. Just change 496 for in, where in is the length. They're going to pass in somewhere else.
Mhm. Yeah.
And then there's a gather here that says I have a bajillion of them. Something like that. So that's morally equivalent to the H2O model without all the H2O internal overhead, because I had to do it in Java. The theory being the bajillion tasks was fork endlessly, so split the data set in half and made 2 tasks, and then look, if they're too big, split again, and endlessly divide and conquer, which on a terabyte data set would get you, 100,000 or 1,000,000 tasks without any trouble at all. Maybe actually
bulk block here is just
tasks.
some collection that supports append.
And then bulk block, yes, exactly. And in fact, in the Java syntax, it was either add or append or something. And it would collect these pending futures, but it would periodically look at the pending futures, and the ones that were completed already, it would just toss out. And in practice, they completed at a high rate. And so it tossed out and kept up. So it internally had a list of pending tasks, but the list never gets very big because they complete in a rapid fashion. So it looks like I can have as many as I want here, and then at the end I can say, okay, now wait on them all. I just spawned literally 1 billion threads, wait on them all, and that was actually efficient in practice.
I'm wondering whether it's really workable to have like this generalized notion of we're just creating our threads or promises or something and do something async in there regardless of what kind of async it is, and whether maybe we just need specific APIs that expose the functionality and the right abstraction level to the user space without
I'm-
trying to push
I'm-
everything through the same concept.
I'm in favor for such a concept that can made the distinction between synchronous and asynchronous, but of course that would be hard to catch all cases.
No, I don't think that's what I was trying to say, but the distinction between use cases, so that you have like an API for networking and an API for IO and an API for whatever, reading config files or something, and that they expose a very specific API designed for exactly this use case. And we are not even trying to say, okay, we are doing some magic async work, and we don't even need to care. We just wrap it in like a new promise or new future, and then we schedule it on a thread pool and something. I feel that that's really backward. I mean, we have like for a long time we had like these terrible libc wrappers around Linux AIO, where the API was so terrible that glibc just built its own thread pool and did things with it. And now we have APIs in the kernel that simply, they are not that thread based, I would say. And I think it's an issue if we have these future or promises APIs that basically say, okay, the first thing we do, we wrap some random item of work into future that spawns a thread when we are executing it. I think that's a really
Okay,
big problem in abstraction.
Okay, in abstraction.
But it doesn't necessarily spawn a thread. It just throws work on a work list.
Was my point. It just mark you for asynchronous work. How asynchronous is implemented?
Yeah, I mean, exactly, because if you're doing, for instance, IO microring, what kind of work list? I mean, the work list is managed by the kernel. You shouldn't even be involved dealing with this yourself in your library, in your language. That's absolutely shouldn't be a concern at all.
So I'm asking, is the correct API that we code to the microring?
Sorry?
The correct API for new language, whether it's AA or Groovy or Rust, is you code to the microring, the IO microring. I claim that is not a good API for a language to code to. So now as an implementation, there's a cost model. How fast is this? There's an implementation, and there's, what the abstraction is, and what is a reasonable abstraction to code to. You said it's not the right abstraction. Okay, what is the right abstraction? I claim the IO microring is not the right abstraction for a language.
And that's why I said I wonder whether we can build APIs for specific use cases, for like, take the IO microring API that, like, let's say you want to do networking. Okay, then let's repackage the required IO microring setup and calls and stuff into some kind of language level API that makes sense for networking, and do the same for file IO. And maybe that's better. I'm not sure.
Well, so that happens anyhow already. And as you pointed out, the C folks did it around the kernel, but the Java folks did it around standard file IO, and then they redid it around NIO, and they added a language that looked reasonable around non-blocking whatever. Now, is that, exposing the Linux kernel or the C library API to the Java programmer? Was that the right API? Maybe not. I think you're going to get a wrapper. Well, what is the right API? What would you rather code to? that still gives you all the low-level performance that you can, love to go get after.
Yeah. The thing is that none of these APIs Java did and redid return futures or promises. So you're not already on the hook for paying this huge complexity on top of your actual domain logic you're trying to do.
Let's go backwards here for a second here. You just said huge complexity for futures. Is that correct? Is that what you think, as opposed to the NIO model in Java, which basically said I started it, and I got a thing back, a socket or whatever, that I could then go ask a question of, is it done yet? Or is it not done? Which is exactly a future. So what is this is still a future here. So I'm missing what API you're suggesting that's different from a future and better than a future. So just saying, the Java version was better than the futures or wasn't complex, but the Java NIO version was exactly a future model. They didn't call it futures, but it's a future model.
How the future concepts is implemented is entirely separate discussion. Does it allocating? Is it boiled down to some kind? That's a separate discussion.
Yeah, but say put the performance to the side. What do you want to code to that you believe performance can happen? I claim I can make futures have performance that are unbelievably fast. So in the cases I'm showing here, the futures were literally a CAS instruction, 10 clocks on an x86. To go flip a CAS to say it went from done to, I knew it and I'm out of here. It's unbelievably cheap. So under that model, assume futures are really cheap. They can be expensive. They're going to wait on the thread spawn or whatever. Maybe it's expensive, but they can be really cheap too. And you get to statistical analysis on it in bulk, cheap. So what's the complaint here on the abstraction, not the performance?
I believe Simon is advocating for a more fine-grained detail about how exactly the futures are tailored to a particular, is it network card, is it a file IO, if I'm understanding correctly, Simon?
Yeah, so basically I don't have a good answer what's the right model. I just see it from a usage perspective. We're going like this. We have threads, then we have futures, then we have await async, then we're trying to do cheaper threads. So I look at this and I wonder, okay, all three things suck, but what's the cheapest one language-wise? What's the one where I'm having to implement the where I'm having to implement the least amount of additional features? And the thing I see with futures is that user experience is absolutely terrible. I mean, you have like these methods that then accept both async, which takes the completion stage, and a by consumer and executor, and I'm just reading from Java doc, and it's absolutely terrible.
So what you're talking about is the thread pool, which is different from the futures. I claim the thread pool implementation out of Java was like really obtusely done.
No, I'm just saying that the future thing is generally extremely complicated to use for the user because all the combinators are nobody understands them. And
I only think about combinators then. I don't think I use any combinators, so I don't care about them. And you've done plenty of futures coding.
Okay.
I have exactly what I would claim exactly one combinator, which is the bulk gather. And everyone else was, I took your result and you ran parallel until I asked for it, and then I had to wait until it was done.
For
and
future,
I had to have a syntax that said, now I want to get the result specifically, not as opposed to, I just used it and that already blocked right away. The blocking point was made obvious for.
I mean, in the end, it's not just the code you write, but also the code other people write. And if I look at the
team of engineers at H2O, I was not the only guy writing this code. And
I mean, if I look at the implementation of completable future in Java, it has like 60 methods, and they are all random words.
Yeah, they're trying to get it all. This shouldn't happen.
Yeah, that's a different one. You can future. Look at futures as a theoretically clean implementation. What did you want to see out of a future? Ignore the thread pool issue. Assume that's handled somehow magically H2O set up
Yeah.
threadful games, but you can ignore
You
that.
want
send OS or the
maybe
language, whatever.
maybe 5 things for a future to block, to run in Mutable, run in synchronous, and
you have to
run
start
both
it.
together.
Yeah, you have to start it. You have to ask the question, am I done without blocking? You have to say block for it and give me the answer back. Now, what else do you actually need? I got like 3 things right now.
Run in parallel,
And it
parallel
happens
and run in synchronous.
as soon as I say get one, it ran in parallel. I don't need to
Cancel.
run.
Cancel, yeah. Okay, asynchronous
Oh,
cancel
cancel.
is hard to
Cancel's-
get, yeah.
Cancel's kind of reasonable and not reasonable. There's issues with cancel. We can call cancel though.
So you have
So
a
this is the API you need. Everything else should not be under futures. It should be under, I'm a complicated, extra special future. And therefore I do, weird things. And you can ask for the weird guy if you want it.
they're
Why
trying
do you
to
need
make
start in the future?
Exceptions are always annoying.
Hmm?
Exceptions in any thread situation are pretty annoying, to be honest.
Well, that's a different question and it's entirely valid. And for me, the answer was I got the exception when I asked for the future result. I got that exception then.
So what are you doing if you need your work, you check is this done, and if it's not done, you spin a lock or something.
There are two different techniques. There's I'm going to ask because if it's done, I'll do something now. Otherwise, I got other things to go do. And then there's block for it. And I'm just going to wait for the result, and you're going to hand me the result or the exception.
And
So
what
if you
about a future with a callback? That's call the callback when the work is done.
No, that's the different model. That's a model that's like the agent model, and you take callbacks. I'm talking. This is the futures model is the callback is what I do when I block for the future, and then I take the result and go. And I said future.get, and then I carried on. That's my callback. So Simon, you're about to say something.
Yeah, maybe. From my perspective, that's just like either you're writing just synchronous code because you're blocking on everything, or you're writing async code, but just way more complicated than using combinators. But yeah, what I want to say is basically futures and stuff is infecting everything. From my perspective, it's also a very complicated API. And then if you go to the next piece of the circle, you end up with async await, which basically says, okay, let's just try to write code.
That we agree that async await was not a great idea, and carry on.
And
the other one is fibers / super cheap thread pools, super cheap threads, where instead of specifically saying I block, I just run the code like it's single threaded, but they're going to block. And I don't care that they block because I got lots of them.
And yeah, and basically you end up with like futures, and futures lead to async await. And if you look at the current
async await, I don't understand where this comes from.
For many languages, it's just a natural progression, and I see it. I mean, people write futures and promises, then they get sick of all the overhead of having to write things that way, and in the end, async await is nothing but like a more convenient syntax for futures and promises.
All right, we have to go code and anger here, because I certainly used a futures behavior out of H2O, and it was not painful in that way. It was a different painful because I didn't get any compiler support for it, but it was not painful that way.
I mean,
so what is the type of a future? It seems like it is just it takes a function that returns an A and it gives you back a function that returns an A, or not done yet, or an exception.
Yeah, your colon A is in the wrong place because that's on the function. It needs to be on the result.
Yeah, I was going to say, where do you put the return value type?
Well, hadn't sorted that one out well.
I'm tempted to call it $A just to be clear that that's a type.
I actually put the type here. So get rid of this colon A. So that would be, and I have a function which returns me an A. It's type. So there's the colon for the type, and then the function returns me an A. So we can argue that that's not what you want to do for forcing a type on the return, and something has to happen. But putting it after the end of the function is it's typing the function itself. And you want to
just wondering if you wanted to share a screen, make this easier for future viewers.
Yeah, okay, fine. That's a good answer. Let's see if
That is a good
Okay.
reminder.
Zoom has gotten back to having correct, reasonable application sharing now. I wonder why it went away last week. Fine. Okay, so I'm just arguing out type syntax for AA, which has nothing to do with anything we're talking here. And then the future here is returning 3 results. It's either returning either returns an A.
And I would say as soon as you have this kind of API, you want to have some kind of combinators over it.
Okay, I hear you say combinators and you don't like it. So why are you saying combinators back to back with I don't like combinators? What's the combinator?
I mean, do you want to write, if you have like 3 operations, do you want to have like a 3 nesting levels with if then else, if this first thing failed, then bail out, otherwise do the second one.
Okay, wait, I'm sorry. Say what your problem is. I would do 3 in a row in parallel. You want a different answer. You want what are you trying to? What is your test case? And I'll write the code for it.
Yeah, you run 3 things afterward, and if one of those, basically, how does the failure part look like? If it fails, you want to bail out with an error message.
I'll do this. It's capitalizing every time. Block plus equal task 3 bulk dot block gets them all, but then I have to go back and come back with the answers I want from each one.
Yeah, but the inputs and outputs are not connected with these operations, from my understanding.
See, I don't have the right syntax here. Here we go. Yes, this is it.
So block is starting as, that's not supposed to be an actual 0, right? That's
Well, in H2O it is, but not H2O. In AA it is. No. But block's a thing that has a call, has a dot block on it. So you're right. This should be a blocker. We'll do it this way. Maybe you like it easier. I'm still making up some API bits because the H2O used a lot more verbose syntax and things here. And so somewhere in the world I'll say res1.get, but I know that the get has completed. So this is non-blocking.
But that's still not connecting the inputs and the outputs.
Oh, you want them 3 things that are one after another?
Exactly, where the result from first,
Why?
if successful, ends up as the input of the second one.
Oh, I'm sorry, that's very different. Let me go wipe this out here, and I don't need a blocker. This is a single thing. This is sys.lazy. And now I'm going to write code that just says run a guy, and then when he's done, feed him into the next thing. And that's, task 1 and then task 2 and then task 3. And then they're all 3 run, because I actually want to run the things.
so that's maybe sequential, but that wouldn't.
That's what
also
you just said. Feed the first one into the second one. They're sequential.
But
Simon is asking, let's say
result
if
as an argument into the second one. I mean, that's what I understood he was asking for,
Yeah.
but
Okay,
No,
yeah.
it's-
Then you just, yeah, that's a good point.
That's what I'm asking exactly.
Yeah, you just said sequential thing.
Input and the outputs are connected of the tasks.
Okay, and that has nothing to do with lazy at all. This is 3 sequential tasks. So you get rid of lazy altogether. You just said task 1 runs and it produces a result that's fed into task 2, which is fed into task 3. So that's a standard, what I write in C code or Java code. Task 1 is not lazy because I need the result immediately, so don't bother making it lazy. I could make it a future and immediately block on the result, but that's a redundant waste of time.
the way
The
that
question is, what happens if task 1 already returns a future?
Okay, so you've already made task 1 a future.
Yeah.
Task 1 is inherently the non-blocking read call from something. Then
So-
you have to follow it with a dot block if you want to make the blocking one.
Yeah, or get for the result or something. Yeah, there's something that says, and now complete a future. And then you don't need the curly here actually, because you're a future already.
So this is a bit different though than I think what I would want out of, so what I would want to be able to compose is that I define a work pipeline,
Mhm.
and the whole thing retains its asynchronous character. And what I return
When
is
you say the whole thing,
like a
you mean-
future.
hang on. When you say the whole thing, you mean I have 3 things to do one after another. I want
Yeah.
them all run, the serial pile run behind my back in parallel. Or do you
Yeah.
mean I have 3 things, they're all going to run independent in parallel? Because they're independent in parallel, they don't take results from one into the next because they're not available, they're running in parallel. So am I running this way or am I running this way?
You're going the first way with your fingers horizontal, I think, but
That's a sequential pipeline. I have 3 things that are just call 1, take a result, call 2, take a result, call 3. Yes.
yeah. So that, but I want the ultimate, like I want my call to the composition to be a future that
Yeah.
returns immediately.
That's what I'm writing. I've all but took out the lazy here.
I
Which
see.
is,
you
you
just
know-
drop the whole thing lazy, but otherwise no
Yeah.
special composition.
Right, drop the whole
I
thing in the lazy.
Yeah, that makes sense. Normally, what I see in JavaScript world is you kind of have this construct where you're saying some future. I don't do a lot of JavaScript, but you do this some future dot on complete.
Yeah,
Here's a function, and then
Right.
some future dot on complete, and so the whole thing is this fairly complex and annoying.
yeah, and that's because the tasks were already returning a future, which you needed to say when it completed, go do this other thing.
Yeah,
And the completionism here is, I'm saying get, so drops future for get, but still, I've been handed from Aaron's conversation, I've been handed 3 tasks which are already returning a promise. They're taking an argument, returning a promise. So I have to get the promise out of each one and go feed them into the next guy.
But how are you handling the errors? That's my question, because that's where combinators get interesting.
Yeah, well, as soon as you say I have sequential code with errors, I'm going to use and. And the fact that there's a blocking left or right inside is unrelated. This is task 1 is returning me an error or result. And this is nothing to do with sequential. I mean, it's nothing to do with parallel at all. This is how do I handle a series of things where I have possibilities of an error and I want to pass one to the next and block. And I don't have I want to say sort of an Elvis operator baked into the language, but I totally could because I have an obvious error code situation for AA, and then maybe you don't like my null as an error answer. But there's task 1 gets evaluated. There was just a lazy here in the middle. And now how do I handle an error back? But I want to pass it as an argument to task 2. So result 1 is task 1. And if that's available, then I can go and then I can say, you know, res 2 is equal to task 2, taking results from res 1 and then this would shorten up if I took an Elvis operator like thing on it.
Can you scroll down a little?
So I mean, aren't you hiding a lot of semantics now in these 2 ampersands?
They're and like C ampersands. They have no other semantics than if the left guy is true, then evaluate the right guy. So
That
if res
assumes
1
that
evaluates to false, which
So how is a future true or false?
so there's no futures here because what you just requested had no futures in it.
No, I
basically
wrote
taking error.
no.
sort of
It's like
But
I
what
wrote
if your task validly returns false?
I wrote down the signatures below, so there are futures everywhere.
Okay, so okay, for this one here, and Derek's got a different question. I need to evaluate the future, and that requires me to do a get call on it. So task 1 gets evaluated. That starts a background operation, would return me a future, which I'm going to do a get and block on it. Then I test for where under the assumption I've agreed that my API returns me a null on a fail and returns me something exciting on a non-fail. But there's other APIs you might like where you have an error code with a string or something instead.
Right.
know,
What if it
I was
returns
just-
a throw?
So I was just thinking about this structure, and it's kind of cool, and was thinking that maybe you should move the get. So I think it needs the get, but it should be in where you're using it as an argument. So you say res1 equals task1 and res2 equals task2, parenthesis
see.
res1 dot get.
Yeah.
And then your true false is just succeeded or failed on the
Okay.
and
So,
with
so
regards to the value that came through.
So there's another version here that I hear you saying, I got a res1 here, but it's actually res1 is a future of an int, because that's what Simon was saying. But I have to do a get here, return a future into an int or some sort of error code, which I don't have then a cutout that says don't call task2 because I had an error. So I'm not doing that version yet.
Yeah, and the and sign there could be that it's completed without an error.
Okay.
It doesn't even proceed past the end if it's not completed, and if it has an error, then
yeah. Okay. So let's
leaves.
change this out a little bit here. There's another version where here and n takes a future on the left, blocks for it, and then calls the right if no error. And the problem I have with that is and doesn't produce an argument to be fed into the next thing. So here it would be, I took a future which is res1, I blocked because the and is special and blocks. Okay, res1 is blocked. Somewhere I have to still say res1.get here, but that blocks already. And I guess maybe you're right. So this would be and blocks and tests for error. No error, I still have to call res1 get because res1 is still a future, and I don't get balanced parentheses matching, so I think I'm missing by one. And then I got a res2 out, which I then and. This is a different version of and. So the blocking happens on the and he does an error check, and then he carries on because he does what and does. That's
If my
different
task throws,
no, yeah, right. So then it comes to
I'm
question,
going
am I
to
allowing
propagate
throws or not?
up through my task,
Yeah.
doing the stack
If any
unwind.
task throws,
And-
the expression there would be the future that threw the exception, and then you can pull the exception out at the end.
These futures are running in order. So I claim the first one to throw is the result of the expression, it's the throw. But that's if you're in a throwing language.
So
right. My question is that, so when someone decides to look at this future, they're going to call .get, and the thing that future is holding is a throw. So it's going to throw when you call .get.
Yes.
So I get this awkwardness of I created my task in some environment.
Yeah.
But when I get my stack trace is going to come up through the task, and then it's going to say, here's where you call .get, and then it's going to give me the environment where I called it. So my throws are going to give me a stack that is very far away from the stack where I probably made my mistake.
Yeah. That was.
So how do I deal with the fact that there's sort of two worlds? On the one hand, as I'm unwinding my stack, I might want to say, well, what was happening when someone called get? And I might want to, as I'm unwinding my stack, want to know what was happening when someone called create task.
This is why people, argue for fibers, is because you get the throw happens in the same context as the fiber that blocked. You just block a fiber, you don't care, and you get a throw, you get it at the context. For H2O, we took a stack frame that included cross-cluster calls and shit. And it eventually, it bounced through the cluster and you got stack traces all the way through.
So you just saved throw context every time someone created one of these tasks that you may or may not be able to use later.
It wasn't that expensive. I blocked the fork join guy. No, the fork join guy, somebody's through and you got the local context of the throw. I pickled that throw stack trace, passed it through blocking context and pick up their stack trace. But it might have been different threads, but the stack was the same, plus or minus layers you got out of fork join. Then you got an OS call over the wire, and then you got a new stack trace on the other side. That makes sense. You did pick up weird layers in the fork join pool where he work stealing and shit like that were going on. But yeah, you got a stack trace that was clearly not from your thread. But it looked like a valid stack trace, as if it had been run from one thread that just bounced through weird layers forever. They were useful. That makes sense, but they were not necessarily local. Like if I looked, you're right, if I looked at my code and I said this code, and then I said, do a get here, but I did a get from a thread, from a fork that had been made somewhere else, never made here at all. So I passed it, if I passed a future across a thread, yeah, you could have a weird stack trace on that future. The stack trace went with the future. But if you didn't pass a future across threads, and no one ever did, you didn't need to. You didn't pass a future across a thread. You put them in the blocker. Blockers took from all threads, but that didn't pass the future across threads. Then you would get a stack trace that was reasonably in your context, except very clearly you crossed the cluster multiple times and you blew up somewhere. And I'm looking at Simon's and variant, which takes a future on the left and blocks on it. I'm not certain I like that.
I mean, my core question is, okay, if the task now fails, I want to recover it with some other computation or some other value and feed that into the...
Well, that would be whatever you do with a default behavior, right? So here's the default behavior on a failing task. And that would be whereas one equal task one dot get, which I then want to do a question mark on, and then I'm going to take, you know, if it succeeded, I want res one. If it failed, I put the default, not a keyword default, whatever the default.
What happens if it's not yet ready?
You want to push the future down in, further in. You would make a new future from an old future that says if this future, which is what I just heard you say there. Okay, then you're going to do another future, which, you know, we can claim sys.lazy is too much typing, but that's a task one. Oops, so don't get task one dot get, you know, this code up here.
I would like to add that the situation becomes much more complex if it's not just a feature, but it's an option of something you have to expect. The inner result can be an either, can be another feature. And I actually, back in the maybe 4 or 5 years, I abused implicit in order to automatically flat map and flatten out the results in order to avoid that constant propagating the result and making new features.
Yeah, the way that we did this kind of shit in H2O was to not make task one have internally what he was going to return you for a default. So he didn't ever return you a fail that you were going to replace with a default. Typically, if a task failed, it was a fail, and
but you encode in the type the fact that first operation, can you return something, but you can return nothing. You are forced to expect to inspect it, either be that is an asynchronous operation, and that leads to a Simon composition, combinators composing that results in order to lead the computation somewhere.
I would have said that I didn't do task one returning a future. That I didn't code by having tasks return futures that I just called sys.lazy or its moral equivalent on a task which returned a value. As soon as you're both recording futures and normal values, you do have the problem that you have to distinguish when it's time to do a get. And now,
yeah, I mean, you usually don't have that choice. I mean, you can't assume that all the code you're writing does not return futures. I mean, where are all the futures coming from that you want to handle if no function returns a future?
So, you know, again, the coding styles I did were the ones for JavaScript using Elm, which hid this behavior under the hood from you, or H2O where they were hidden from you in bulk array operators. So you wrote sequential code around bulk array operators, where the bulk arrays would span a cluster and be terabytes.
But yeah, but that's I mean, if you can get away with parallel computing,
Yeah,
then,
and then the engineers who wrote the
it
H2O
doesn't
guts
matter.
dealt with this internally. And they had to deal with knowing they got a feature back or not. And wasn't too bad, but we had much more structured code. We occasionally had mathematicians write in the bulk array operators. That happened a few times, and they got it figured out.
Cliff, your ... type can't be instantiated, right? If anyone ever tries to evaluate ... that just throws a not implemented error.
That's the current theory on it, yeah. And uncatchable might go in the debugger, but it's not going to
So
be.
can a value be of type A or ...
Well, I don't have any or types, but you could have a type being I assume you have a type being the ... whatever it's going to be as a type, yeah.
Right, because I want to have a future that says, okay, my future is a type that if I call block, it gives me back the A by either calling the function because it's not done, so we wait on it, or by returning the result if it is done. I want to call done, which gives me a Boolean and says either true, I've got a value for you, or false, I don't have a value for you.
Well, done would be a field. You don't have to have a function to call done, but yeah, fine. Yeah, okay, you have a function for it. Yeah, you have a function for it. Yeah, you have
because you're going to have to
yeah,
keep
fine.
looping back around.
Yeah,
But
no,
this,
that's fine.
And then
Okay.
finally, you want to have a value that if I'm done gives me an A.
Oh, and otherwise it gives you.
If I try to resolve value well done is false, I actually want that to explode. So like I could make that nil, which is fine,
But
and
you
just
make
be
it
like, hey,
nil.
if you checked the value, but you didn't check if it was
No,
done first, you're
If you
stupid.
want it to explode, you have to have a function here. So then value is a function, not a field. And then as a function, you check the done flag and it's not set, you explode. Right. So if you make this a value, you declare value a function, then the implementation is, done question mark ... colon the underlying value, which you don't hasn't been exposed here.
Well, it's a type, I'm just saying.
Yeah, right. Yeah, I understand you're trying to type things. So there's an underlying value of type A here. Whoops, where did that come from? Oh, my cursor's weird here. So assume underlying. Oh God, it thinks I'm in. Hang on, it thinks I'm in comment mode. Oh, weird. Okay. So assume
I guess
underbar
that's
means-
sort of my answer is I have my thing that I called block,
Yeah,
which will call the function if it doesn't, but that returns my value anyway.
yeah,
So I don't actually need value. Value can be an entirely private field and say the only functions that I expose are done tells you if you're done.
yeah. And
block
yeah,
blocks.
which you can just replace with get. Is a little bit shorter. And this will block
Right. If I
block
don't
that
check
field.
if I'm done and I call get, my consequence to that is simply that I block.
Yeah.
Rather than I get some really weird undefined behavior.
Yeah, right.
So if I
Very
want to
good.
make sure that I never block, I just have to always check done before I call get.
Yes. Yes.
And if I call get without checking done, I've just implicitly said I'm willing to block now.
Yeah.
But then you
So
have
does my API need to be anything more than the done and the get?
Yeah, I want to hear Simon's complaint.
Yeah, I mean, then you're arriving exactly at that level where like, okay, I have checked done, I'm not done. I would actually like to write codes like what should actually happen if this thing over there is done. And then you
Okay, as soon as you're asynchronous, you have the problem that it's not done. And of course, the clock cycle after you check it, it becomes done. But you asked for it's done, it's not. Now you can go do something else while you're waiting and come back around.
I didn't
Okay.
get that.
And all these asynchronous computing behaviors, there's sort of the done or not is answered on the clock cycle. And you can fail, you can be done the clock cycle after you bother to check. Also in all asynchronous behaviors, if you're not done, you're going to do something in parallel. why did you ask for done, except to go do something else while you were waiting, but you have an unlimited amount of other stuff to go do, because otherwise you would just get it all done and then call your get. So you don't want to do an unlimited amount of stuff and then call get. So you sometimes want to say done, and then if it's done, oh, I'm going to go now do a get. But if it's not done, I'm going to go back to my unlimited pile of things. So my unlimited pile of things is I'm running a clock that ticks around the screen forever, and I want to keep checking, am I done, to go do my done shit. But if not, I keep bumping my clock. Something like that. So done is a weird one, but people use them all the time, but it's still a weird one, because it does mean I could do what I want when the thing's ready, or I could do this other thing. But if I have two choices, why don't I just make futures and block on them both? So done is a little weird one. It exists, everyone loves it, it's weird. Using it in a reliable, good, efficient, concurrent coding style is actually difficult, because if you have a limited shit to be done, and they both have to be done, why, you don't ever call done. You just say, I have two things to go do. I go do them both in parallel. I block on them both, and I'm done.
Yeah, so that's just the API.
Yeah.
Promise.done, do stuff with the value or do other stuff.
Mm-hmm.
Yeah, the more I hear of this, the more I'm unconvinced that this is.
Please produce a better API, and that doesn't match the other bad APIs that we've all agreed are bad.
I mean, that's before we went on this incursion, that was basically my point, saying the promises stuff is really complicated. The async await stuff is even more complicated. If you look at what SIG does, or what Rust now does with like the async generic ideas, and the thing is, okay, what's the cheapest way to like get to do multiple things without paying the cost? Because the thing I'm seeing, sorry.
You can make the cost to actually run these things in parallel like super duper cheap.
No, not the computation cost. So the language cost,
the language
complexity of.
Yeah. Okay. I'm gonna make sure we're separating the concern of overheads of making a future or forking a task or starting a thread, are separate from the language costs where you pollute the language with all these gets. In my case, I have a bajillion gets because it's the futures and gets.
Yeah. Because the things I'm seeing here with the API is basically we are basically reinventing combinators, except we are not calling them combinators. But I mean, if Java had operator overloading maybe there, then combine async method would also be just end. Because that's where basically.
So this could happen with,
Yeah, I mean that's the thing you're saying. Okay, it's just as simple. We have this get, we have maybe done, and here we write this code. But 3 lines down, we have already invented some kind of ampersand that does magic stuff, and that's pretty much we are basically have invented our first combinator. So that's kind of the complexity I'm talking about when I'm talking about futures and promises.
Yeah, and if I look at Cameron's solution in Ecstasy, he has services for which you explicitly know that it's a service, and you have to do a get to get the result out of the service. And he has blocking and unblocking calls to decide you're going to block right now and you don't need the get call, or you're going to do the non-blocking call, and you have to go specifically and ask for it. You look at Erlang, it's a similar operation. You went across a service boundary, you went across a channel, you specifically knew you were going to a channel because of the typing, and you specifically blocked or didn't on the result that came out of the channel. So in all these cases, there is a syntax that said it went sequentially in line, in parallel, in a row with no extra syntax, or I had it's a future syntax and I did a get on the result at some point later.
That I think as soon as you're doing a lot of these future operations, you basically end up at the point where you say, okay, I don't want to check for done and decide stuff every time. I don't want to write a if, I don't want to write a get. I just want to say, here's my future. If this future returns successfully, do another piece of work that also returns a future. And then if this future is done, use the successful value of this and run it in another, run the result.
So what you said was, I wrote 3 futures in a row, each dependent on the prior one. Therefore, they're not in parallel. They are sequential. I'm just writing sequential code. It happens to have been wrapped in futures, and I want to get rid of the future wrap sort of silently somehow or cheaply, but I'm just writing sequential code, and I got the wrong API because I got a fucking task returning me a future, and I don't want the task returning me a future. I just want the task returns me the value. So how do I convert a thing returns me a future to a thing returns me a value? And then I can just run them sequentially one after another.
And that's push the conversation to something. Go ahead.
Yeah, and that's basically where you end up with combinators, when you basically don't want to deal with that anymore. Or you go, I mean, like saying, okay, this function returns a promise, but I don't want it to return a promise. I think this is futile. If you look at JavaScript, write code for some time, and suddenly half your code returns promises, and you can't do anything about it.
I think a step in the right direction should be a smarter for comprehension that can unwrap all of the unnecessary operations that you do when you combine the features with the combinators. But that's my opinion, of course.
Yeah, I really like the virtual thread idea that Java had, because it doesn't invent new language stuff to expose it to the user. You have just normal Java method calls, and I mean, maybe this approach sucks as much as the future approach and as much as the async await approach, but it's, from a language complexity perspective, really cheap because it doesn't do anything new. And
right.
Yeah.
So that one is the model that says it's really cheap to spawn a thread, like really cheap, because I'll just block and then it comes back to me.
Yeah, or because like there is no thread underneath, neither at a user space nor at the kernel side.
You separate out what the user codes to what how the model makes it efficient. Right, that's a thing. Is as soon as you said, yeah, because there's no thread underneath. No, maybe there is a thread underneath. There has to be a thread somewhere, but maybe it's super cheap. You said, oh, it's a fiber. That's a fucking thread. Fiber runs on a thread. There's totally an OS thread.
That was my argument, just to make the language mark something that can be asynchronous and leave the implementation separate.
Yeah. So there's another version that says, oh, this is your do stuff, where I list a series of things, or maybe this one says do stuff in the middle. There's a version that says I have a series of things and I want them to all run in parallel and then block on them all at the end. You have blocks in the middle. But if I sys.lazy a set of things, and then there's another version that says do all these things in parallel. And these are all thunks, B, C, right? And it gives me back a future for them all, which I'll do a pound go get. And I get the result of whatever it means to run 3 things in parallel. Maybe it gets a tuple back. So there's a version of lazy that just takes 3 things to run in parallel. What I see here with the do stuff, I don't know who wrote it, but that just runs a background thunk that runs the first guy, waits on it, runs the second guy, waits on it, runs the third guy, waits on it, and returns the third guy. Which means that it's running 3 things sequentially, bulkily in parallel to the main thread.
At which line are you?
Well, I'm looking at whatever. I don't know what somebody wrote. Do stuff here. Oh. What is the intention of this code? Somebody wrote it. I don't know who wrote it.
That each of the 3 tasks depends upon the previous task, but you still want the whole thing to be done in the background.
Yeah. You call do stuff with a P, it launches and returns the result of a syslazy, which is a future. So you get a future out of do stuff. When that future completes, you get the last task, but the 3 tasks are sequential. Now I've replaced stop block with pound sign as a short operator to say block for, and shove them one inside the other is what I would do. So here's another version of do stuff.
Right, but my instinct is to read it differently. If I see do lazy ABC, I don't assume that they're chained in any way. My assumption would be they could be done in any order, and that I have no guarantees of the order in which A, B, and C will execute.
The point of syslazy is they're done in any order. The ABC I wrote, and you have a sequential order for them, which is fine. And here I want a thing which is run task 1 with a P and block on it, feed that into task 2. And I'm not going to claim this is easier to read, but maybe. And block on that, feed that into task 3. And I don't need a block on it because that's what I'm going to hand back to syslazy anyhow. Oh no, maybe I do want to block on it. I do want to put it into syslazy. We're missing the thing we're missing there is and the result of task 3 goes into the outer syslazy that it just got added onto. That was a thing we did in H2 all the time. I'm trying to think of the right way to do it here, but it doesn't really matter for this example. So that's a version, the same behavior as what you wrote above, just written in one line because I'm experimenting with how it looks. And then, it's uglier. Or it's far, far denser, but it's the same behavior. It's run task 1, then 2, then 3, feeding results from one to the next. And the whole thing is in the lazy, so I can call do stuff with some P and get a future back that I have to get on, and it waits all 3. As soon as I call do stuff with a P, it starts running 1, 2, 3.
Maybe there's a way of using function composition and lazy, so like combine them. Like imagine if you could create a sys.lazy, but you had a way of specifying that it took some arguments, so it actually wouldn't start executing until it was basically called like a function. And then you could compose it with
well, syslazy is a function that takes an argument, which happens to be a future.
Sorry, the result of syslazy. Right? So
okay,
so
the result of syslazy is a future.
So right, but imagine that if you could have a way of calling it that it took the resulting future actually was actually a future wrapped in a lambda that took an argument, and so maybe so
right. I hear what you're saying.
This would be a good idea, but
you're trying to chain futures
it
together.
It would make this ability. So then you could use function composition and have a syslazy that looked very clean, maybe.
Right.
So but you don't need a new language feature for that. You can totally have the thing that your lazy thing returns be a function.
Yeah, that's right. And it could take arguments, and so then that produces a lazy at some point.
Right. If you want to use some library that does partial function application and combine that with lazy, those should combine just fine and be like, I gave you 2 parameters and you did a lazy thing and then came me back on result, and then I gave you the last parameter and you gave me the final result.
Yeah. So I don't know if any additional language feature are needed, but it might be a nicer way of doing than this sort of mechanism that we're looking at here with all those hash signs in it.
Well, the hash sign was my operator overload that just says .get.
Yeah.
Which I don't necessarily like, but I'm looking at it. It's like,
But it still seems like get and done are all the API you need for futures. Earlier, we were listing like 5 or 6 different functions you would want for a future. Why do I want anything more than just
well, there's cancel, which is a funny deal because not everything can be canceled. If you're already done, you can't be canceled. If there's some cost to the cancel, like, and then there's collection of resources and mid computation and the like. So there's a thought that I want to have a cancel, but I don't get any guarantees that I didn't complete before I canceled.
And if you completed, then when you cancel, do you still have the valid result?
Yeah, the cancel just ignores and you keep the valid result. So certainly H2O supported cancel, and it was always a funny game because the cancel would chase after the endless forking in front of it, trying to catch up to the forks. And the race was on where the cancel would catch up to the fork. And there's a scheduler, and you had to try and schedule cancels ahead of more forking, or else, you know, the cancel would never get to the top of the list. The job would be done, and the cancel would be like the next thing on the work queue. And you're like, oh,
I
we'll
guess
go
my
cancel
response
now.
to that would be, I don't want a cancel function on my futures. I want a cancel function on my work pool. If I call sys.lazy and that sticks something in a work pool, I want sys.lazy.workpool.cancel, and I hand it the future and say, hey, by the way,
Yeah,
I'm
but you
holding
don't
this
know-
future. If it's in the
Right.
work pool, pull it out of the work pool.
But you don't know what the implementation of lazy is doing. So that's why cancel wants to go in the future plus everything that future forks internally. That's why you put the cancel in the future, because otherwise you have an implementation that claims I have a work pool. Maybe I don't have a work pool. Fuck you, I don't want a work pool. I have some other implementation under the hood. There's no work pool. My other implementation is just ran these things in sequentially in order anyhow, and there were no work pool. That's what I'm saying. Don't claim a work pool.
And yeah, and I guess you could keep a tree of dependency and then just kill the whole tree.
You
Leaves
can't kill a
first.
tree instantly. You kill a tree by walking its parts. The leaves are all tasks that are busy building the tree ahead of you.
Right.
This what I'm talking about. This is the race that you had to go through. It was never very reliable to efficiently call cancel if you also had an efficient way to fork work. Now, once you got down to you're done forking and every core was busy doing work, if cancel showed up, you somehow had to have it higher priority. Oh, there's that priority problem again. Higher priority than the work that was getting done. And then the work pools would themselves, when they reached for work, check the cancel somewhere and decide that there's a cancel. I'm going to propagate it ahead of other work. And that touched all these other tasks. And I found and fixed them all one after another. And eventually they got the cancel bit. And then when I pulled a dude off the work list and, you know, some other core, he'd look and say, there's work to be done. It's not yet done, and it's canceled. I'll leave it canceled.
Right. So cancellation could also negatively impact non-canceled work.
Oh, totally.
Yeah.
Yes. It was cancel was an ugly hammer to implement, and to actually have it cancel really meant that everyone else had to pay a price when cancel showed up. And most folks paid a modest price when cancel didn't show up for cancel, but when a cancel showed up, it was ugly. These things on these large data sets, if they were well forked and well running in parallel, the individual tasks would run through megabyte of data or a couple megabytes of data in like milliseconds, like memory bandwidth on compressed data sets is really efficient. So cancel had to be faster yet than milliseconds across networks, or it didn't actually cancel anything. Then also all your cores are busy. So the guy who's responding to a network packet probably got a job in there to, he threw something out, but making sure that then had precedence to go stop more work happening was a trick.
So when I control C, I get this interrupt that percolates up through my stack that goes, nothing in your program handled the control C, therefore your program died. Here's your backtrace.
Yeah, that was not always the world. The usual world was
it feels
the OS
like you could do
in.
something analogous here and be like, hey, if your future got canceled by something somewhere, by whatever mechanism canceling exists, you just get my state is I am done, and my result is here's an exception, you got canceled.
Yeah, you cancel error. Yeah.
So
that's
it still
all.
feels like I don't need anything in the API for future about cancel. It's just if there is a mechanism by whatever task scheduling system I'm using to cancel, then one of the possible results is I got canceled exception.
Okay, I'm sorry, how do you invoke a cancel?
With whatever task scheduling system you're actually using in your specific application.
So the cancel goes on presumably on a specific future and not on all futures. The future and its forked children, but not an unrelated future and its forked children. Right? I have two futures I've spawned. They each going to fork internally, sort of semi-indefinitely doing large works. I want to cancel the first one, let the second one run. How do I indicate that?
So maybe you need to have a cancelable future as a different kind of future that then does the bookkeeping to try and make the cancellation
cancel efficient. Yeah, the issue, of course, is all the work's done on the shared common implementation of thread pooling and networking and how you respond to task packets and shit over the wire and whatever. And so everyone pays the price anyhow, even if you don't have an implementation, even if you choose not to cancel. You running the non-canceling implementation, it's going to route to the same backend that has canceling support in it, and that's where all they.
I was just thinking that maybe there'd be some bookkeeping that you wouldn't want to do for normal ones, but as soon as you're in cancelable world, then everything inside it becomes well, it becomes tied to the one that can be canceled, and then you end up with a shallower tree, which has got a higher branch factor. Where the ones that, or like assuming that not everything is getting called as cancelable, and so then you can sort of more efficiently nail the things that you need to cancel quickly if you cancel something. Like you have certain pointers to everything that you know that you need to cancel.
The problem is when I pull somebody off the general rules, I pull somebody off a work queue. The guy's going to pull it off is going to look at the value or the done flag and then immediately launch into doing work. And then as soon as he's done, he goes right back to the work queue. While he's running doing the work, that guy makes a new future. Okay, so the cancel shows up somehow. He has to find all the children, and there's not an obvious correlation to go find the children of the guy who's.
Well, that's what I'm saying, that like once you're executing a cancelable future, the thread that's doing that work needs to know that if a future is spawned, it needs to be tied to this high branch factor cancel tree for the separately for every or I don't know, like for every future
like, go
is
implement
cancelable
and
in your history.
It's like go implement, you'll go see. It's always the case that the thing that you think you want to go do is always already too late, and you have to go get the the hard thing has to happen in your face all the time. It all sounds like I should be able to do it this way, and you never can. You have to always go do the hard thing in the hot inner loop.
At least if you know that you're in a cancelable tree, then you can also tell that tree that it's been canceled, and so then spawns at least can get
so a reasonable answer is that every cancelable future has a pointer to some original future that says I'm part of this tree, and he'll only have to go one layer and test a bit.
One trick they used is every future of the chain points to the root, to the first future.
Yeah, and this only works if you only cancel at the root. And
canceling inside.
And so now you have layers where I'm running a GUI-based H2O driver where I'm clicking for terabyte tasks, and then I cancel some and I click some more, and these are all running in parallel concurrently. And the root is the task that's running the GUI per se, and he forks and forks and forks or whatever. Multiple people fire up multiple GUIs because they're attaching to the same cluster, the same data set, and asking different questions. There is no one actual root. So I can declare roots, but I have to have nested roots. So I have basically shortcuts. A cancel means stop here, and anyone in the middle here should get canceled. But then I have another cancel guy here.
Yeah.
It's not part of this guy.
I believe that's doable. Let's say if you have 10 futures, there are only 2 points that you can interrupt them. If you make them to trace the work, that's always more expensive. If you make a breakpoint, if you can break the 5 future or the first future, that's reasonable compromise between the. If you cancel work, you have to always trace the future chain, because some of the futures may be being on your computer, some of the futures may be on other computer, and that's
part of the trace is going cross cluster, and so that's a different. That's part of the same issue, but it's a different.
It's tangent to the cancellation.
But somewhere on my one shared memory machine, I had a tree of cancel points. Some point in the middle got whacked to a cancel. Every time I fire a task, I crawl that tree looking to see if a cancel bit's set. That's the ugly way to do it, right? That's the thing. But every time because many of these tasks I fork, I say milliseconds because I'm doing big data, but there were plenty of them that I ran that were microseconds or less.
That's why I said, if you have a 10 futures, you can interrupt it basically at only 2 points, because it will be executed between 2 points.
And it will be
Yeah.
executed, yes, in between, yes.
That's a workable approach, I believe.
So that's a separate problem though. Let's claim that there's a future API that has no canceling, and then there's an API that we add cancel, and it's difficult to implement it well. And people who write the future bodies don't necessarily want to think about how they implement cancel. So you want the implementation of future itself to deal with canceling under itself somehow, and not make the users. I made the users of the bodies deal with cancel, which typically meant mathematicians who were writing a custom version of an H2O bulk thing didn't cancel. And my system engineers who were writing the common everyday shit, they canceled well.
Even more, that asynchronous work is not the main purpose of your program. It's just, you just want to be asynchronous and be done with it. And you don't want to deal with cancellation versus not cancellations. You just
if I'm
want
doing a GUI
asynchronous.
thing, we actually do cancels and GUIs all the time, actually. If I'm doing a Photoshop and I'm doing a image processing hack or whatever, and then the guy hits no, and he hits the escape or the break or whatever.
You want to cancel.
You want to cancel, yeah. Fuck.
Yeah.
This is very
All right.
remnant of Erlang's supervisor trees, right?
Yeah, right.
Yeah.
That's
It's the
exactly
same.
what we're
In
talking
fact, I
here.
was thinking
Same.
about that before.
Yeah, this is what we're talking here.
Okay.
So I came in with, I was hoping I'd have a chance. Obviously it's too late now, but I want to mention that I made some progress on my sea of nodes implementation. I've got the whole parse done and the SSA. I sort of followed this easy SSA slide deck and a couple of your papers and stuff. It's coming out really nicely. So I actually did 2 versions of it. I did it from later in my IR and then moved it closer to the beginning, and it worked much better.
Can we schedule you for the next meeting that you gave us a brief?
Yeah, I was gonna say it's
easy SSA. It's the way to do SSA. Fine.
You keep a list of notes or something where you say, okay, this wasn't clear, or I figured this out.
We're headed for 3 hours here. Let's do it next time. I can present the SSA again. It's like a 10-minute slide deck. It's really
I was just wondering if if Derek keeps notes so that maybe there's a new revision of the paper that's like even more accessible or something.
Oh yeah, sure. I could probably talk it through. I don't have too much notes, but yeah, I'd like to. It'd be fun to show it off. I already have something I can working, but then I guess I missed the part about libraries and imports, and I had a bunch of stuff I was kind of interested to show separately related to that too. I'm pretty happy with, but
next time.
Yeah, I also have stuff for
It
next.
will be SSA heavy session.
All right.
It won't really be. I
string
mean, I've got it
thing.
sorted. It's really like sea of nodes, but I expect that by next week I'm gonna have like a bunch of people optimizations done.
Super.
Cool.
Nice.
I thought Simon, you had a string hash thing in there. You had
Yeah,
progress on core.
Let's do it next time.
Next time. Cool. Okay.
Yeah.
Till we meet again.
Okay, guys. Bye.
Bye.
Goodbye.
Bye.